Welcome, friends. I'm so glad you're here. Whether you're drifting towards sleep, unwinding after a long day, or simply looking for a quiet companion, you found the right place. Before we begin, I'd love to know, where in the world are you listening from? Perhaps you're wrapped in a blanket, sitting by a softly lit window, or resting somewhere under an open sky. Wherever you are, I hope you're warm, comfortable, and ready to wander with me into the depths of space and time, where stars are born in cosmic nurseries and our sun may once have had a twin. If you find peace or curiosity in these gentle stories, please consider liking the video, subscribing to the channel, or sharing it with someone who might need the moment of stillness too. And to those who've already joined along, thank you. In the vast darkness between stars, where space seems empty and silent, enormous clouds of gas and dust drift through the galaxy like cosmic fog. These molecular clouds, some spanning hundreds of light years, contain the raw materials for stellar birth. Each cloud holds enough matter to create thousands of stars, yet it drifts through space with the density of Earth's best laboratory vacuum. The contradiction settles into the mind with gentle irony. What appears empty actually teems with the building blocks of stellar creation. The clouds move through galactic space at speeds that would terrify terrestrial travelers, racing at tens of thousands of miles per hour around the galaxy's center. Yet from the perspective of cosmic time, they barely seem to move at all. A molecular cloud maintains its basic structure for millions of years, its vast bulk rotating slowly like a celestial carousel made of hydrogen and helium, sprinkled with heavier elements forged in the nuclear furnaces of long-dead stars. Within these stellar nurseries, temperatures hover just above absolute zero, creating conditions more frigid than any earthly winter. At negative 400 degrees Fahrenheit, matter exists in a state of patient waiting that spans geological ages. Water molecules freeze solid to dust grains, forming tiny crystals that drift like microscopic snowflakes through the interstellar medium. Carbon monoxide, ammonia, and dozens of other simple compounds coat these frozen particles, creating a vast library of chemistry suspended in the cosmic cold. The darkness between the dust grains stretches for distances that dwarf planetary scales. If a dust particle were enlarged to the size of a marble, its nearest neighbor would sit several miles away. This profound emptiness creates a silence more complete than any earthly quiet. No air to carry sound waves, no atmosphere to generate weather, just the gentle electromagnetic whispers of molecules absorbing and emitting radiation at radio wavelengths. Gravity works slowly but inevitably in these stellar nurseries, like a cosmic sculptor chiseling away at raw material with infinite patience. Tiny variations in density, perhaps triggered by the shockwave from a distant supernova or the gravitational influence of a passing star, create seeds of future stellar systems. These density fluctuations represent mere whispers of change, regions where the cloud contains perhaps one extra hydrogen molecule per cubic meter. Yet these microscopic variations will eventually determine where stars ignite and where empty space remains. The process unfolds with the geological patience that makes mountain formation seem hurried by comparison. Gas molecules drift together grain by grain, building mass so gradually that a human lifetime represents barely a whisper in the cloud's transformation. Generations of civilizations could rise and fall, while a single stellar nursery prepares for its moment of birth. The universe operates on timescales that render human urgency meaningless, transforming vast regions of space through processes so gradual they approach the meditative. Magnetic fields thread through these molecular clouds like invisible highways, guiding the motion of charged particles and creating structure within apparent chaos. These magnetic lines of force, thousands of times weaker than a refrigerator magnet yet spanning light years in extent, help determine how collapsing gas will fragment into individual stellar cores. The interplay between gravity, magnetism, and turbulence creates a delicate balance that has persisted unchanged since the galaxy's youth. Only after countless millennia does the accumulating matter reach the critical threshold where collapse becomes inevitable. The transition happens gradually, then suddenly, like a landslide that builds tension grain by grain until the entire mountainside surrenders to gravity. Dense cores within the cloud begin contracting faster than sound can travel through the rarefied gas, creating regions of increasingly concentrated matter that will eventually ignite nuclear fusion. When stellar birth finally begins, it rarely produces solitary stars like hermits in the cosmic wilderness. The collapsing cloud fragments into multiple dense cores, each destined to ignite its own nuclear furnace. Stellar twins and triplets emerge from the same gravitational womb, born within astronomical distances of each other but linked by invisible threads of mutual gravitational attraction. The universe seems to prefer stellar partnerships, cosmic companions locked in gravitational embrace for billions of years. Binary star systems dominate galactic stellar populations with quiet persistence. More than half of all stars exist in gravitational partnerships, their orbital dances spanning timescales that make geological epochs seem brief. Some stellar twins orbit each other in hours, their surfaces nearly touching as they whirl through space like cosmic figure skaters. Others maintain distances measured in light years, taking millions of years to complete a single orbital revolution around their common center of mass. The mathematics of stellar companionship creates endless variations on gravitational themes. Stars can orbit in perfect circles, long ellipses, or complex patterns that trace intricate geometric shapes across centuries. Mass ratios determine the choreography. Nearly equal stars dance as partners, while mismatched pairs create systems where massive primaries dominate tiny secondary companions. The universe has been experimenting with these gravitational arrangements for over 13 billion years. This preference for stellar twins presents a quiet mystery that hangs in the darkness like an unanswered question. If most stars form in pairs or groups, why does our sun drift through space alone? The statistical improbability settles into contemplation with gentle weight. Our solar system's solitary architecture may represent an exception rather than the rule. Perhaps our star once had a companion that vanished into the galactic night, leaving behind only subtle gravitational echoes in the arrangement of distant comets. The search for our sun's hypothetical twin has occupied astronomers for decades, though the evidence remains frustratingly elusive. Computer simulations of stellar formation suggest that single stars like our Sun should be uncommon. Yet here we orbit a solitary nuclear furnace that appears to have always travelled alone. The contradiction creates a cosmic puzzle that may never find complete resolution. The irony settles gently over this cosmic meditation like stellar dust accumulating over eons, in a universe where stellar loneliness appears unusual. Our Sun carries its family of planets through space as a singular entity. Only took 4.5 billion years to notice we might be different. The molecular clouds continue their patient work, birthing new stellar partnerships while our solitary star maintains its quiet journey through the galaxy's spiral arms, perhaps mourning a companion it never had, or perhaps celebrating an independence that allowed the delicate chemistry of life to flourish on a small blue world. In the deepest cold of interstellar space, where stellar nurseries drift between the galaxy's spiral arms, the raw materials for countless future suns continue their ancient wait. The process that created our Sun continues unchanged, patient and inevitable as cosmic time itself. Stars ignite across the cosmic web like metabolic fires, converting hydrogen into helium in nuclear furnaces that burn for millions or billions of years. This stellar metabolism mirrors cellular respiration in ways that extend far beyond mere analogy. Just as living cells break down glucose to release energy, stars fuse lighter elements into heavier ones, releasing photons that travel across vast distances to power planetary systems and drive the chemistry of life. The universe consumes its simplest components to create complexity, a process that has continued without interruption for nearly 14 billion years. Within each star, hydrogen nuclei overcome electromagnetic repulsion through quantum tunneling, a process so improbable that it should rarely occur. Yet stellar cores maintain temperatures and pressures that make these impossible reactions routine, sustaining nuclear fusion across cosmic timescales. 4 hydrogen nuclei combine to form one helium nucleus, releasing energy equivalent to converting a small portion of matter directly into light. This mass-energy conversion follows Einstein's equation with mathematical precision, but the underlying quantum mechanics remain as mysterious as the biochemical processes that animate living cells. Red dwarf stars burn their hydrogen fuel so slowly that they can sustain fusion for trillions of years, far longer than the current age of the universe. These stellar organisms represent cosmic longevity beyond human comprehension, maintaining steady energy output across timescales that encompass the rise and fall of entire galactic civilizations. More massive stars burn brightly and die young, exhausting their nuclear fuel in mere millions of years before collapsing into neutron stars or black holes. The stellar life cycle parallels biological metabolism. Some organisms burn energy slowly and live for centuries, while others metabolize rapidly and complete their life cycles in days or hours. Supernovae scatter heavy elements throughout interstellar space, seeding the cosmic web with carbon, oxygen, silicon, and iron, the building blocks of rocky planets and organic chemistry. These stellar deaths serve as cosmic reproductive events, spreading genetic material through the galactic environment where it can contribute to new generations of stars and planetary systems. Without supernova nuclear synthesis, the universe would remain composed almost entirely of hydrogen and helium, too simple to support the complex chemistry that makes life possible. The interstellar medium absorbs this stellar output, creating vast molecular clouds where new stars eventually form. These cosmic nurseries contain the raw materials for planetary formation, concentrated through gravitational collapse over millions of years. The process resembles cellular division, where accumulated resources reach a critical threshold before organizing into new structures. Stellar formation requires precise conditions. Insufficient density produces nothing, while excessive density creates black holes that consume rather than create. The universe maintains this delicate balance across billions of simultaneous stellar births. Brown dwarfs exist at the boundary between stars and planets, too massive to remain cold but too small to sustain hydrogen fusion. These failed stars glow dimly with leftover heat from their formation, slowly cooling over billions of years like dying embers in a cosmic fireplace. They represent metabolic processes that never quite achieved self-sustaining fusion, cosmic organisms that remain forever on the threshold between life and dormancy. Recent discoveries suggest brown dwarfs might be more common than actual stars, a hidden population of substellar objects drifting through the galactic web. Binary star systems demonstrate cosmic symbiosis, with two stellar organisms orbiting their common center of mass while exchanging matter and energy. In some cases, a white dwarf star accretes material from a red giant companion, periodically igniting in nova explosions that illuminate entire star clusters. These stellar partnerships can persist for billions of years, their orbital dance gradually spiraling inward as gravitational waves carry away angular momentum. The process mirrors symbiotic relationships in biology, where two organisms benefit from their intimate association across extended periods. Stellar winds carry charged particles throughout planetary systems, creating magnetospheres around planets with strong magnetic fields. These cosmic circulatory systems distribute energy and matter across interplanetary space, influencing atmospheric chemistry and climate patterns on any worlds that happen to intercept the flow. Earth's magnetosphere deflects most solar wind particles, but some penetrate near the magnetic poles to create auroral displays that reveal the invisible connections between stellar and planetary systems. Pulsars spin with clockwork precision, emitting regular pulses of radio waves that astronomers can detect across vast distances. These neutron star lighthouses result from stellar core collapse so extreme that atomic nuclei merge into exotic matter denser than atomic nuclei. A teaspoon of neutron star material would weigh as much as a mountain. Yet these objects rotate hundreds of times per second while maintaining timing accuracy that rivals atomic clocks. They represent stellar evolution carried to its logical extreme. Matter compressed beyond normal physical limits, yet somehow maintaining coherent structure and behavior. The stellar initial mass function describes how many stars form at different mass ranges, a cosmic recipe that remains remarkably consistent across different galaxies and cosmic epochs. For reasons not fully understood, the universe preferentially creates low-mass stars over high-mass ones, ensuring that stellar fuel reserves last for trillions of years rather than burning out in cosmic moments. This stellar demographics resembles population ecology in biological systems, where reproductive strategies and resource allocation follow patterns that optimize long-term species survival. Stellar metallicity increases over cosmic time as successive generations of stars enrich the interstellar medium with heavy elements. The oldest stars contain almost no elements heavier than lithium, while younger stars like the Sun incorporate carbon, oxygen, and iron produced by earlier stellar generations. This cosmic chemical evolution parallels biological evolution, where genetic complexity increases over time through accumulated mutations and recombinations that create new possibilities for form and function. Variable stars pulsate with regular periods that reveal their internal structure and evolutionary state. Cepheid variables serve as cosmic candles, their intrinsic brightness related to their pulsation period in ways that allow astronomers to measure galactic distances. These stellar heartbeats provide rhythm and timing across cosmic scales, like circadian clocks that regulate biological processes within living organisms. The universe maintains its own temporal patterns, cycles within cycles that organize cosmic processes across multiple scales of space and time. Only took a few 100 million years for the first stars to ignite after the Big Bang, transforming a dark universe into a luminous web of stellar metabolism that continues burning today. The cosmic organism began generating its own energy, no longer dependent on leftover heat from its violent birth, achieving a kind of stellar photosynthesis that converts simple elements into complex chemistry through nuclear fire. Gravitational waves ripple through space-time itself, carrying information across the cosmos at the speed of light like neural impulses traversing a vast cosmic mind. These distortions in the fabric of reality were predicted by Einstein's general relativity, but remained undetected for a century. Invisible messages propagating through dimensions beyond human sensory experience. When two black holes spiral into each other billions of light years away, their final collision sends gravitational tremors that eventually reach Earth, causing laser interferometers to register length changes smaller than 1/10,000th the width of a proton. The universe whispers its secrets through geometry itself. The Laser Interferometer Gravitational Wave Observatory detects these cosmic vibrations by measuring infinitesimal changes in distance between mirrors suspended in perfect vacuum chambers. Each detection represents a catastrophic event somewhere in the deep cosmos. Stellar mass black holes merging, neutron stars colliding, or perhaps exotic processes not yet imagined by human science. These gravitational signals arrive carrying information encoded in space-time curvature, describing masses, spins, and orbital dynamics of objects so extreme that they exist at the boundaries of physical possibility. LIGO's detection network spans multiple continents, creating a planetary sensory system capable of triangulating gravitational wave sources across the observable universe. When gravitational waves pass through Earth, they stretch and compress space-time along perpendicular axes, creating interference patterns that reveal the wave's amplitude, frequency, and direction of origin. This cosmic triangulation resembles how biological nervous systems process sensory information, combining inputs from multiple receptors to construct coherent representations of environmental conditions. Gravitational wave astronomy reveals a previously hidden universe populated by colliding black holes and merging neutron stars. Cosmic violence that occurs in complete electromagnetic silence. These cataclysmic events produce no light, no radio waves, no X-rays, only gravitational disturbances that propagate across billions of years and light years to reach terrestrial detectors. The universe contains entire categories of phenomena invisible to traditional astronomy. Cosmic processes that communicate exclusively through space-time geometry rather than electromagnetic radiation. Neutron star collisions create gravitational wave signatures, followed milliseconds later by gamma-ray bursts, demonstrating how cosmic catastrophes generate multiple types of signals that race across the universe at different speeds. These kilonova events forge heavy elements like gold and platinum through rapid neutron capture processes, then scatter them throughout the cosmic web where they eventually incorporate into new stellar and planetary systems. Gravitational waves carry advance warning of these element-forging explosions, like neural signals preceding muscular contractions in biological organisms. Binary pulsar systems provide natural laboratories for testing gravitational wave theory, their orbital decay precisely matching Einstein's predictions for energy loss through gravitational radiation. PSR B 1913+16, discovered in 1974, has been losing orbital energy for decades at exactly the rate predicted by general relativity. Indirect confirmation that gravitational waves exist even when they remain too weak to detect directly. These cosmic clockworks demonstrate how space-time itself carries energy and momentum, substantiating the deeper unity between matter, energy, geometry, and information. Primordial gravitational waves, if they exist, would carry information from the universe's inflationary epoch when space-time itself underwent exponential expansion. These hypothetical signals would reveal conditions during the first fraction of a second after the Big Bang, encoding details about cosmic inflation, quantum fluctuations, and the fundamental physics that shaped reality's initial conditions. Detecting primordial gravitational waves would provide direct access to the universe's embryonic development, like discovering fossil DNA from the first living cells. The cosmic gravitational wave background represents accumulated signals from every binary merger, stellar collapse, and violent cosmic process throughout the universe's entire history. This background noise would contain information about cosmic evolution, stellar formation rates, and the distribution of compact objects across different cosmic epochs. Future gravitational wave detectors might decode this cosmic symphony, extracting individual signals from the accumulated gravitational chatter of 14 billion years of cosmic evolution. Gravitational memory effects occur when gravitational waves permanently alter the space-time geometry they traverse, leaving subtle distortions that persist long after the wave has passed. These space-time scars represent a form of cosmic memory, where the universe retains information about past gravitational wave events embedded in its geometric structure. The cosmos might literally remember every significant gravitational disturbance, encoding this information in space-time curvature patterns that could theoretically persist for billions of years. Black hole mergers produce gravitational wave signatures that reveal their masses, spins, and orbital characteristics with remarkable precision. The final moments before collision generate chirp signals that sweep upward in frequency as the black holes spiral closer together, like cosmic bird songs that encode detailed information about the singers. These gravitational chirps allow astronomers to weigh black holes with greater accuracy than any electromagnetic observation, demonstrating how space-time distortions can serve as precision measuring instruments across cosmic distances. Eccentric binary systems generate gravitational waves with complex harmonic structures that reflect their orbital geometries and evolutionary histories. Unlike simple circular orbits that produce clean sinusoidal signals, eccentric binaries create gravitational wave patterns containing multiple frequency components and amplitude modulations. These complex signals carry more information about their sources, like musical compositions that reveal the instruments and acoustic environments in which they were performed. Spinning black holes dragging space-time around themselves create additional complications in gravitational wave signals. Frame dragging effects that encode information about angular momentum and rotation rates. These lens-thurring precessions cause orbital planes to wobble over time, creating gravitational wave signatures that sweep through frequency space in characteristic patterns. The universe's most extreme rotating objects leave their fingerprints in space-time curvature, cosmic signatures that reveal internal structure through gravitational, rather than electromagnetic emissions. The network of gravitational wave detectors continues expanding, with planned space-based observatories that will detect signals from supermassive black hole mergers and galactic-scale binary systems. The Laser Interferometer Space Antenna will position 3 spacecraft in triangular formation millions of kilometers apart, creating a gravitational wave detector larger than Earth's orbit around the Sun. This cosmic-scale instrumentation will reveal gravitational processes currently beyond terrestrial detection capabilities, opening new windows into cosmic phenomena that communicate exclusively through space-time geometry. Gravitational waves travel at exactly the speed of light, neither faster nor slower, suggesting fundamental connections between gravity, electromagnetism, and the structure of space-time itself. This precise speed limit indicates that gravitational information cannot travel faster than electromagnetic information, maintaining cosmic causality and preventing paradoxes that would arise if gravitational effects could precede their electromagnetic counterparts. The universe maintains strict information flow protocols that preserve logical consistency across all physical processes and scales. Only took 4 billion years for intelligence to evolve on Earth and develop technology sensitive enough to detect gravitational waves from cosmic collisions, a remarkable convergence of biological evolution and cosmic violence that allows the universe to become aware of its own gravitational processes. The cosmic mind develops sensory capabilities through conscious observers, extending its perception across space-time dimensions that remain forever hidden from electromagnetic astronomy. Dark matter flows through the cosmic web in vast filamentary streams, creating an invisible circulatory system that connects galaxies across billions of light years, like arteries carrying nutrients through a living body. These hidden currents comprise over 80% of all matter in the universe. Yet they interact only through gravitational forces, remaining forever beyond direct observation while shaping every visible structure in the cosmos. Computer simulations reveal how dark matter streams converge at galactic intersections, pooling into massive halos that provide gravitational scaffolding for ordinary matter to collect and condense into stars and planets. The Millennium simulation maps dark matter's flow patterns across cosmic history, tracing how tiny quantum fluctuations in the early universe grew into the vast web of filaments visible today. Dark matter particles, whatever they might be, began clustering within the first few million years after the Big Bang, creating gravitational wells that ordinary matter eventually filled like water flowing into riverbeds carved by invisible currents. This cosmic watershed system channels matter across distances so vast that individual filaments span hundreds of millions of light years, yet maintain coherent structure and directional flow for billions of years. Galactic halos extend far beyond their visible boundaries, invisible spheres of dark matter that can stretch for millions of light years around each galaxy. The Milky Way sits embedded within such a halo, our entire stellar system floating like an island within an ocean of gravitationally bound dark matter that outweighs all visible stars by at least 10 to 1. This cosmic embedding suggests that what humans perceive as separate galaxies might actually represent visible manifestations of much larger dark matter structures, like leaves on branches of an invisible cosmic tree. Dark matter substructure creates complex flow patterns within galactic halos, streams and clumps that reveal the merger history of each cosmic region. When dark matter halos collide and merge, they create tidal streams that can persist for billions of years. Ghostly rivers of particles flowing through galactic neighborhoods like blood vessels carrying cosmic nutrients to sites of active star formation. The Sagittarius stream stretches across the entire sky, a ribbon of stars and dark matter being slowly consumed by the Milky Way's gravitational appetite. Gravitational lensing reveals dark matter's distribution through its effect on light from distant galaxies, creating cosmic mirages that distort and magnify background objects. Massive galaxy clusters bend space-time so severely that they act like gravitational telescopes, focusing light from galaxies billions of light-years beyond them. These lensing effects map dark matter concentrations with remarkable precision, revealing clumpy distributions that match theoretical predictions, while confirming that most cosmic mass remains forever invisible to electromagnetic observation. The bullet cluster demonstrates dark matter's existence through collision dynamics that separate ordinary matter from its gravitational source. When two galaxy clusters collide at thousands of kilometers per second, their hot gas clouds interact electromagnetically and slow down, while their dark matter components pass through each other largely unimpeded. Gravitational lensing reveals that most mass remains concentrated around the galaxies themselves rather than the hot gas clouds, proving that visible matter represents only a small fraction of cosmic gravitational influence. Weak lensing surveys measure subtle distortions in galaxy shapes across vast regions of sky, statistical signatures of dark matter's gravitational influence that accumulate over cosmic distances. Individual galaxy distortions remain imperceptible, but when millions of galaxy images are analyzed together, dark matter's cosmic web becomes visible through its cumulative gravitational effects. This statistical astronomy reveals dark matter structure on scales ranging from individual galaxy clusters to the largest cosmic filaments spanning billions of light-years. Dark matter direct detection experiments search for these invisible particles in underground laboratories shielded from cosmic ray interference. These detectors wait patiently for dark matter particles to collide with atomic nuclei and crystalline targets. interactions so rare that detecting a single event would represent a major scientific breakthrough. The cosmic circulatory system might flow directly through human bodies and laboratory equipment, carrying invisible matter through every terrestrial location while remaining completely unnoticed by conventional senses and instruments. Axions, sterile neutrinos, and weakly interacting massive particles represent theoretical candidates for dark matter's identity, exotic forms of matter that interact only through gravity and possibly weak nuclear forces. These hypothetical particles would have been produced in enormous quantities during the universe's first moments, then dispersed throughout cosmic space, where they continue flowing along gravitational gradients established by cosmic expansion and structure formation. Dark matter streams might contain information about cosmic conditions during the universe's inflationary epoch. Fossil currents that preserve details about reality's initial configuration. Cosmic void regions contain much less dark matter than filamentary structures, creating zones of reduced gravitational influence where cosmic expansion proceeds more rapidly than average. These voids grow larger over time as dark matter flows out of them toward denser regions, creating an increasingly empty cosmic anatomy, where ordinary matter becomes increasingly rare. Void expansion resembles biological growth processes where nutrients flow from less active regions towards sites of rapid cellular division and metabolic activity. Dark matter annihilation could produce gamma rays, neutrinos, or other detectable particles when dark matter particles collide with their antimatter counterparts in regions of high dark matter density. Galactic centers and dwarf satellite galaxies represent promising locations for detecting these annihilation signals. Cosmic laboratories where dark matter concentrations might reach densities sufficient for self-interaction. The cosmic circulatory system might be slowly consuming itself through particle-antiparticle annihilation, converting its own substance into detectable radiation. Fuzzy dark matter theories propose that dark matter consists of ultralight particles with wave properties that become significant on galactic scales. These quantum waves would create interference patterns that suppress small-scale structure formation while maintaining large-scale filamentary flow patterns. If dark matter exhibits wave-like behavior, the cosmic circulatory system might operate through quantum interference effects that organize matter, flow through mechanisms completely foreign to classical physics and biology. Self-interacting dark matter models suggest that dark matter particles can collide with each other through forces other than gravity, creating viscosity effects that modify flow patterns within galactic halos. These collisional processes would thermalize dark matter distributions, creating more spherical halo shapes and affecting satellite galaxy orbits in ways that might be observationally detectable. The cosmic circulatory system could exhibit fluid dynamics properties that make it behave more like biological circulation than simple gravitational clustering. Dark matter mapping projects like the Dark Energy Survey and Euclid mission will measure dark matter distributions across billions of galaxies, creating detailed maps of cosmic circulatory patterns throughout the observable universe. These surveys will reveal how dark matter flows evolved over cosmic time, whether circulation patterns remain stable or exhibit temporal variations that might indicate cosmic metabolic processes. The universe's circulatory anatomy will become visible through statistical analysis of gravitational lensing effects accumulated across cosmic volumes. Warm dark matter scenarios predict that dark matter particles possess small but non-zero velocities that smooth out the smallest scale structure while preserving large-scale filamentary architecture. These thermal velocities would create a minimum scale for dark matter clumping, preventing the formation of very small dark matter halos while maintaining the cosmic web's overall circulation patterns. The cosmic circulatory system might operate within well-defined scale limits that prevent excessive fragmentation while ensuring efficient matter transport across galactic distances. Modified gravity theories attempt to explain galactic rotation curves and cosmic structure without invoking dark matter, suggesting that gravitational laws themselves might differ on cosmic scales from their terrestrial forms. These alternative theories face the challenge of explaining gravitational lensing observations and cosmic microwave background patterns without additional invisible matter, requiring gravitational modifications that remain mathematically complex and observationally controversial. Only took 9 billion years for dark matter's circulatory system to transport enough ordinary matter into the local galactic neighborhood for planet formation and biological evolution to begin, a cosmic cardiovascular process that continues operating today, pumping invisible matter through galactic arteries while nourishing stellar formation in ways that remain forever hidden from electromagnetic observation. Black holes patrol the cosmic web like immune cells, consuming matter that threatens galactic stability while regulating star formation rates through feedback mechanisms that extend across millions of light years. These gravitational guardians range from stellar mass objects formed through supernova collapse to supermassive giants containing billions of solar masses. Cosmic vacuum cleaners that maintain galactic health by preventing runaway star formation and clearing debris from galactic centers. Their event horizons mark boundaries where space-time curvature becomes so extreme that even light cannot escape, creating cosmic quarantine zones that isolate the most dangerous gravitational infections. Supermassive black holes anchor nearly every large galaxy, their gravitational influence extending throughout their host stellar systems while their accretion processes regulate cosmic chemistry through jets and winds that can sterilize entire galactic regions. These central engines consume gas, dust, and occasional stars while ejecting high-energy particles and radiation that travel thousands of light-years before depositing their energy in the surrounding interstellar medium. The feedback loop between black hole feeding and galactic star formation resembles immune system regulation, where white blood cells release chemical signals that coordinate organism-wide responses to threats and injuries. Active galactic nuclei blast relativistic jets across cosmic distances. These narrow beams of particles and magnetic fields carving cavities in galaxy clusters while redistributing energy and matter throughout the cosmic web. Radio galaxies extend these jets for millions of light years, creating cosmic lighthouses that remain visible across vast distances while clearing paths through the intergalactic medium like cosmic snowplows. When these jets encounter dense gas clouds, they trigger shock waves that can either stimulate or suppress star formation depending on local conditions and jet energies. Gamma-ray bursts represent the universe's most violent immune responses. Stellar mass black holes forming through hypernova, explosions that release more energy in seconds than the sun will produce over its entire 10 billion year lifetime. These cosmic sterilization events can strip atmospheric ozone from planets hundreds of light years away, creating extinction events that reset biological evolution while clearing galactic neighborhoods of potential threats to cosmic stability. Long-duration gamma-ray bursts appear to originate from the collapse of massive stars in low metallicity environments, cosmic locations where stellar evolution proceeds along more primitive pathways. Tidal disruption events occur when stars venture too close to supermassive black holes, their stellar material stretched into luminous streams that spiral around the black hole before disappearing beyond the event horizon. These cosmic feeding events produce characteristic light curves that brighten and fade over months or years, stellar destruction signatures that illuminate black hole properties while demonstrating the universe's capacity for consuming its own stellar children. The process resembles cellular autophagy, where organisms digest their own components to maintain metabolic balance during periods of stress or starvation. Intermediate mass black holes occupy the mysterious middle ground between stellar and supermassive varieties, cosmic objects that might represent evolutionary links between different black hole populations or entirely distinct formation mechanisms. These elusive gravitational entities could populate globular clusters and dwarf galaxies, serving as immune system components that operate on intermediate scales between individual stellar systems and entire galactic structures. Their existence remains controversial, with observational evidence remaining frustratingly sparse despite theoretical predictions for their cosmic abundance. Black hole mergers detected through gravitational waves reveal cosmic immune system evolution, showing how these gravitational guardians combine to form more massive protectors while releasing enormous amounts of energy through space-time distortions. The LIGO-Virgo detection network has revealed a population of stellar mass black hole binaries with masses and merger rates that challenge theoretical predictions, suggesting that cosmic immune systems operate through mechanisms not fully captured by current stellar evolution models. Primordial black holes could have formed during the universe's first moments when density fluctuations reached extreme values, creating a population of cosmic immune cells that predates star formation by hundreds of millions of years. These hypothetical objects might constitute part of dark matter, invisible gravitational guardians that influence cosmic structure formation while remaining undetectable through electromagnetic observation. If primordial black holes exist in sufficient numbers, they could represent the universe's original immune system, established during cosmic inflation to regulate matter distributions throughout subsequent cosmic evolution. Hawking radiation predicts that black holes slowly evaporate through quantum effects at their event horizons, gradually returning their mass energy to the cosmic medium while maintaining perfect thermal equilibrium with their surroundings. This quantum evaporation process operates over timescales that dwarf cosmic history for stellar mass black holes, but microscopic black holes would evaporate rapidly in bursts of high-energy particles and gamma rays. The universe's smallest immune cells might self-destruct through quantum processes. Cosmic antibodies with built-in expiration dates. Black hole information paradox highlights fundamental mysteries about how cosmic immune systems process and store information about the matter they consume. Quantum mechanics suggests that information cannot be destroyed, yet general relativity implies that anything falling into a black hole disappears forever beyond the event horizon. This paradox touches on deep questions about cosmic memory and whether the universe's immune systems preserve records of everything they sterilize, or whether some cosmic information becomes genuinely lost. Magnetic field amplification around black holes creates cosmic particle accelerators that boost charged particles to extreme energies before launching them across galactic distances. These magnetospheric processes operate like cosmic immune system factories, manufacturing high-energy cosmic rays that travel throughout the galaxy while carrying information about black hole feeding processes and magnetic field configurations. The cosmic ray flux reaching Earth includes particles accelerated by black holes throughout the Milky Way's history, cosmic messengers that reveal immune system activity across vast distances and timescales. Fast radio bursts might originate from magnetar black hole interactions, or other exotic processes involving extreme gravitational and magnetic fields. Cosmic signals that could represent immune system communications or byproducts of cosmic sterilization events. These millisecond radio flashes carry enormous energies across cosmic distances. Brief but intense signals that might encode information about cosmic immune responses occurring in distant galaxies billions of years ago. Black hole thermodynamics suggests these cosmic immune cells possess temperature, entropy, and other thermodynamic properties that scale with their mass and angular momentum. Larger black holes maintain lower temperatures while possessing higher entropy. Cosmic fever patterns that might regulate galactic thermal balance through mechanisms that operate on gravitational rather than electromagnetic principles. The universe's immune system might exhibit thermal regulation properties that maintain cosmic health through gravitational rather than chemical processes. Cosmic censorship hypothesis proposes that nature prevents the formation of naked singularities, ensuring that extreme gravitational collapse always produces event horizons that hide singularities from external observation. This cosmic modesty principle might represent a fundamental immune response that protects space-time geometry from causality violations and other pathological effects that naked singularities could produce. The universe maintains its own logical consistency through gravitational mechanisms that quarantine mathematical infinities. Only took stellar evolution several billion years to produce the first black holes through supernova collapse, establishing cosmic immune systems that continue operating today through gravitational sterilization processes that remain forever hidden behind event horizons where even light cannot survive to carry information about cosmic quarantine procedures. The cosmic microwave background radiation carries patterns that could represent genetic information encoded in the fabric of reality itself. Temperature fluctuations measured at just millionths of a degree that contain the blueprints for all cosmic structure formation. These subtle variations in the universe's afterglow preserve fossil impressions of quantum fluctuations from the inflationary epoch, when space-time itself underwent exponential expansion that stretched microscopic uncertainty principles into cosmic-scale architectural plans. Like DNA molecules carrying hereditary instruction for biological development, the microwave background contains encoded information that determined where galaxies would form, how matter would cluster, and ultimately where conditions suitable for life would emerge. Planck's satellite measurements reveal cosmic microwave background anisotropies with unprecedented precision, mapping temperature variations across the entire sky to create the most detailed portrait ever obtained of the universe's primordial information content. These measurements detect polarization patterns that encode details about cosmic inflation, dark matter interactions, and the fundamental physics that operated during the universe's first fraction of a second. The cosmic genetic code appears written in photon polarization angles and temperature gradients that require sophisticated statistical analysis to decode their underlying meaning. Baryon acoustic oscillations leave characteristic signatures in the cosmic microwave background, sound waves that propagated through the primordial plasma before the universe became transparent to light. These cosmic sound patterns created regular spacing in matter distributions that persist today as subtle correlations in galaxy clustering, fossil acoustic signatures that reveal cosmic composition and expansion history. The universe's genetic code includes musical elements, harmonic frequencies that shaped matter distributions through acoustic rather than chemical processes. Cosmic inflation theory predicts that quantum fluctuations in hypothetical inflaton fields generated the initial density variations that evolved into cosmic structure. Microscopic uncertainty principles amplified to cosmic scales through exponential space-time expansion. These quantum seeds would carry information about fundamental physics at energy scales far beyond any terrestrial experiment. Cosmic DNA that encodes details about grand unified theories and quantum gravity effects. If inflation occurred, the cosmic microwave background contains genetic information about physical laws that operated under conditions more extreme than stellar cores or particle accelerators. Non-Gaussian signatures in cosmic microwave background statistics could reveal information about cosmic initial conditions that differs from simple random fluctuations. organized patterns that might indicate more complex genetic mechanisms operating during cosmic inflation. Higher-order correlations and topological features in temperature maps could encode details about inflation field interactions, cosmic phase transitions, or even information processing that occurred during the universe's earliest moments. The cosmic genetic code might contain syntactic structures and organizational principles that transcend simple statistical randomness. Cosmic strings, if they exist, would create distinctive signatures in the cosmic microwave background through gravitational effects that produce characteristic temperature patterns and polarization signals. These hypothetical topological defects would represent cosmic genetic elements that preserve information about symmetry breaking during cosmic phase transitions. One-dimensional structures that could stretch across the observable universe while maintaining internal coherence. Cosmic string networks might function like chromosomes, organizing cosmic genetic information along linear structures that influence large-scale cosmic development. Primordial gravitational waves would imprint distinctive patterns in cosmic microwave background polarization. Tensor modes that carry information about cosmic inflation and quantum gravity, effects during the universe's earliest moments. Detection of these primordial gravitational signatures would provide direct access to cosmic genetic information from energy scales approaching the Planck limit, where quantum mechanics and general relativity merge into unified descriptions of space-time geometry. The cosmic genetic code might be written in space-time curvature itself, rather than matter distributions. Dark matter interactions during the radiation-dominated epoch could modify cosmic microwave background patterns through effects on photon diffusion and acoustic oscillation damping. Genetic modifications that reveal dark matter properties and interaction cross-sections. Subtle deviations from standard predictions might indicate that dark matter particles interact through forces other than gravity. Cosmic genetic variants that could explain dark matter's role in cosmic structure formation. The cosmic genetic code includes instructions for invisible matter that outweighs ordinary atoms by more than 5-to-1. Cosmic topology investigations search for repeated patterns in cosmic microwave background maps that might indicate finite universe geometries. Cosmic genetic palindromes that would reveal whether space-time possesses overall closure or infinite extension. If the universe exhibits non-trivial topology, the cosmic microwave background would contain correlated temperature patterns at widely separated sky locations, genetic echoes that reflect cosmic boundary conditions. The cosmic genetic code might be written on curved surfaces that loop back on themselves in dimensions beyond direct perception. Reionization signatures appear in cosmic microwave background polarization at large angular scales. Genetic modifications introduced when the first stars and galaxies ionized intergalactic hydrogen several 100 million years after cosmic recombination. These secondary effects reveal information about early star formation, supermassive black hole growth, and cosmic chemical evolution during the universe's adolescent phase. The cosmic genetic code includes instructions for stellar ignition and galactic assembly that activated long after the initial genetic information was encoded. Cosmic variance limits precision measurements of cosmic microwave background fluctuations at large angular scales, fundamental uncertainty principles that prevent perfect knowledge of cosmic genetic information even with ideal observational instruments. The universe contains only finite volumes at each angular scale, creating sampling limitations that introduce irreducible noise into cosmic genetic measurements. The cosmic genetic code includes uncertainty principles that prevent complete genetic determinism, even when observational technology achieves theoretical perfection. Sunyaev-Zeldovich effects modify cosmic microwave background photons through interactions with hot gas in galaxy clusters, secondary genetic modifications that occur billions of years after the original genetic encoding took place. These thermal and kinematic effects create shadows and distortions in microwave background maps that reveal cosmic structure formation and cluster evolution. The cosmic genetic code undergoes epigenetic modifications through interactions with cosmic matter distributions that developed according to original genetic instructions. Anomalies in cosmic microwave background statistics challenge standard cosmological models through unexpected correlations, asymmetries, and large-scale patterns that might indicate cosmic genetic irregularities or observational systematics. The cold spot, hemispherical asymmetry, and quadrupole-octopole alignment represent potential cosmic genetic mutations or environmental effects that modified standard genetic expression. The cosmic genetic code might contain errors, damage, or modifications that create observational puzzles requiring new theoretical interpretations. Future cosmic microwave background missions will achieve even greater sensitivity and angular resolution, potentially detecting primordial gravitational wave signatures and measuring cosmic genetic information with precision that reveals quantum gravity effects and inflation dynamics. These next-generation measurements might decode cosmic genetic mechanisms that remain hidden in current observational noise, accessing genetic information from energy scales where spacetime itself undergoes quantum fluctuations. Only took 380,000 years for the cosmic genetic code to become observable as the universe cooled sufficiently for atoms to form and photons to travel freely, preserving genetic information in electromagnetic radiation that continues carrying cosmic hereditary instructions across 14 billion years of cosmic evolution and expansion. The universe's expansion mirrors cellular mitosis on cosmic scales, space-time itself stretching like dividing cytoplasm while maintaining its essential organizational patterns across billions of years of continuous growth. Dark energy drives this cosmic cell division through a mysterious repulsive force that comprises 70% of cosmic energy density, accelerating expansion at an ever-increasing rate that suggests the universe might be approaching some fundamental transition phase. Like a biological cell preparing for division, cosmic space grows larger while preserving the information and structure necessary for continued development and complexity generation. Cosmic inflation during the universe's first fraction of a second represents rapid cellular expansion that increased cosmic volume by factors of 10 circumflex 26 or more. Exponential growth that stretched quantum-scale fluctuations into cosmic-scale structures while maintaining causal connection across regions that would otherwise remain forever isolated. This inflationary expansion resembles the rapid cell growth that occurs during embryonic development, when cellular volumes increase dramatically while genetic information guides organizational processes that establish fundamental body plans and anatomical structures. Scale factor evolution describes how cosmic distances increase over time according to the Friedmann equations. Mathematical relationships that govern cosmic expansion rates based on matter density, dark energy density, and space-time curvature. These cosmic growth equations predict how the universe evolved from its initial hot, dense state through radiation-dominated and matter-dominated epochs into the current dark energy-dominated phase. Cosmic mitosis follows precise mathematical laws that determine expansion rates and evolutionary pathways with the same regularity that governs biological cell cycles and growth patterns. Hubble's law reveals that galaxies recede from Earth with velocities proportional to their distances, a cosmic expansion pattern that indicates every location in the universe experiences the same expansion rate relative to its immediate neighborhood. This uniform expansion resembles how cell division occurs simultaneously throughout growing tissues, with every cellular region participating in coordinated growth that maintains overall organizational integrity. while increasing total system volume. The cosmic cell grows from within rather than expanding into pre-existing space. Type Ia supernovae serve as cosmic distance indicators that reveal dark energy's existence through observations showing that cosmic expansion has been accelerating for the past 5 billion years. These stellar explosions occur when white dwarf stars exceed the Chandrasekhar mass limit, creating thermonuclear detonations with remarkably consistent peak brightness that allows astronomers to measure cosmic expansion rates across different cosmic epochs. The discovery of cosmic acceleration suggests that the universe's mitotic process has entered a new phase characterized by exponential rather than decelerating growth. Dark energy's equation of state parameter W determines how cosmic expansion will evolve in the future, with W equals sign -1 corresponding to constant dark energy density that produces exponential expansion continuing forever. Current observations suggest W remains close to -1, indicating that dark energy behaves like Einstein's cosmological constant rather than evolving scalar fields or other dynamic components. The cosmic cell might be programmed for eternal expansion, growing larger without limit while gradually diluting its matter and energy content. Vacuum metastability represents a potential threat to cosmic cellular integrity. The possibility that quantum fields exist in false vacuum states that could decay spontaneously and destroy the current cosmic order. If the Higgs field or other fundamental fields occupy metastable configurations, quantum tunneling could trigger phase transitions that propagate at light speed while fundamentally altering physical laws and particle properties. The cosmic cell might be vulnerable to quantum decay processes that could terminate its expansion and reorganize its entire constitutional framework. Big Rip scenarios predict that accelerating cosmic expansion could eventually overcome gravitational binding and tear apart all cosmic structures, from galaxy clusters down to individual atoms and subatomic particles. If dark energy density increases over time rather than remaining constant, cosmic expansion could accelerate so rapidly that it overpowers all fundamental forces and disintegrates every organized structure in the universe. The cosmic cell's mitotic process might be programmed for self-destruction rather than stable division. Cosmic microwave background observations constrain cosmic curvature to within 1% of perfect flatness, indicating that cosmic geometry remains nearly Euclidean despite billions of years of expansion and gravitational evolution. This geometric flatness requires remarkable fine-tuning of initial conditions, cosmic flatness that must have been established during inflation with precision exceeding 1 part in 10 circumflex 60. The cosmic cell maintains perfect geometric proportions during its expansion, suggesting sophisticated regulatory mechanisms that preserve spatial relationships across cosmic scales. Redshift surveys map cosmic expansion through spectroscopic measurements of galaxy recession velocities, three-dimensional surveys that reveal how cosmic structure evolved over billions of years while participating in overall cosmic expansion. These redshift distance relationships confirm Hubble's law across vast cosmic volumes, while revealing subtle deviations that encode information about dark energy properties and cosmic matter distributions. The cosmic cell's expansion history remains preserved in electromagnetic radiation from galaxies at different cosmic distances and evolutionary stages. Cosmic horizons limit the observable universe to regions within approximately 46 billion light-years, beyond which cosmic expansion has carried matter outside the range of electromagnetic communication. These horizons represent the cosmic cell's sensory boundaries, limits beyond which information cannot propagate due to finite light speed and cosmic expansion effects. The cosmic cell possesses limited self-awareness, able to observe and influence only a finite fraction of its potentially infinite total volume. Multiverse theorists suggest that cosmic inflation might produce multiple expanding regions with different physical laws and initial conditions. Eternal inflation that creates infinite numbers of cosmic cells undergoing mitotic division throughout a metacosmic space. Each cosmic cell would evolve according to its own physical constants and quantum field configurations, creating vast populations of universe organisms with diverse properties and evolutionary trajectories. The cosmic mitosis might be occurring simultaneously throughout dimensions beyond direct observation. Heat death represents the ultimate fate of cosmic expansion if dark energy remains constant. Thermal equilibrium that will be reached when cosmic expansion has diluted matter and energy to negligible densities while increasing entropy to maximum values. The cosmic cell would eventually reach thermal and chemical equilibrium, a state of maximum entropy where no further organization or complexity generation can occur. Cosmic mitosis might lead inevitably to cosmic senescence and death rather than successful reproduction. Cyclic cosmology models propose that cosmic expansion might reverse into contraction phases. Cosmic cells that undergo complete life cycle including birth, growth, maturity, senescence, death, and rebirth through infinite sequences of cosmic expansion and collapse. These cyclic models suggest that cosmic mitosis represents only one phase of larger cosmic life cycles that include both expansive and contractive periods, extending across timescales vastly longer than current cosmic age. Only took 13.8 billion years for cosmic expansion to increase the universe's size by factors exceeding 10, circumflex 26, while maintaining the organizational complexity necessary for galaxy formation. Stellar evolution, planetary development, and biological evolution. Cosmic cellular division that continues accelerating today through dark energy processes that remain fundamentally mysterious despite precise observational characterization. Galaxies within clusters exhibit cooperative behaviors that transcend simple gravitational attraction, sharing matter and energy through processes that resemble symbiotic relationships in biological ecosystems. Ram pressure stripping occurs when galaxies move through hot intra-cluster gas, their interstellar medium swept away like leaves in cosmic wind while triggering enhanced star formation in galaxy cores through compression effects that concentrate remaining gas into stellar nurseries. These galactic interactions create mutually beneficial relationships where stripped matter enriches the intra-cluster medium while compression triggers evolutionary changes in galaxy morphology and star formation rates. The Virgo cluster contains over 1,300 galaxies bound together in gravitational embrace across 10 million light-years of space, a cosmic ecosystem where individual galaxies undergo continuous interaction through tidal forces, gas stripping, and occasional mergers that reshape galactic structure over billions of years. Central elliptical galaxies grow through systematic consumption of smaller cluster members, cosmic predators that maintain ecosystem balance by preventing overcrowding while recycling galactic matter into more massive and stable configurations. The cluster's hot gas atmosphere regulates star formation rates throughout member galaxies, creating negative feedback that prevents runaway stellar reproduction. Intracluster light reveals populations of orphan stars scattered throughout galaxy clusters, stellar refugees stripped from their parent galaxies during gravitational encounters that left them wandering in intergalactic space. These homeless stars continue nuclear fusion while drifting between galaxies. Cosmic nomads that contribute to cluster luminosity while demonstrating how galactic symbiosis redistributes stellar material across cosmic neighborhoods. Intracluster stellar populations could eventually comprise significant fractions of cluster mass. Diffuse stellar atmospheres that surround galaxy clusters like cosmic suburbs Galaxy harassment describes ongoing gravitational perturbations that occur when cluster galaxies pass within each other's gravitational influence. Tidal interactions that trigger morphological evolution from spiral to elliptical configurations over multiple orbital periods. These cosmic encounters resemble social interactions in biological communities, where individual organisms modify their behavior and structure in response to neighbor proximity and competitive pressures. Harassed galaxies often develop disturbed morphologies, asymmetric structures that reveal their interaction histories through stellar distribution patterns and kinematic signatures. Starburst galaxies within clusters undergo episodes of intense star formation triggered by gravitational interactions or gas compression. Cosmic reproductive events that consume gas reserves rapidly while producing massive stellar populations and heavy element enrichment. These galactic baby booms typically last tens of millions of years before gas depletion terminates star formation, leaving behind aging stellar populations and enriched interstellar media. Cluster environments both trigger and quench starburst activity through complex feedback mechanisms that regulate cosmic reproduction rates. Active galactic nuclei modify cluster environments through relativistic jets and winds that heat intra-cluster gas while redistributing energy across millions of light years. Central black holes that function like cosmic thermostats regulating cluster-wide temperature and chemical composition. These feedback processes prevent catastrophic cooling that would otherwise trigger massive star formation episodes, maintaining cluster thermal equilibrium through mechanisms that operate across scales from individual black holes to entire galaxy clusters. The symbiotic relationship between central engines and cluster environments demonstrates cosmic homeostasis. Brightest cluster galaxies occupy cluster centers where they continue growing through ongoing accretion of smaller galaxies. Cosmic apex predators that maintain their dominant positions through systematic consumption of cluster resources. These giant elliptical galaxies often contain multiple stellar nuclei, fossil evidence of merger events that assembled their enormous stellar masses over billions of years of cluster evolution. Their growth rates correlate with cluster mass and richness, demonstrating how ecosystem structure influences individual organism development. Galaxy-galaxy lensing reveals dark matter distributions within galaxy clusters through gravitational effects on background galaxy images. Weak lensing signatures that map invisible matter concentrations while demonstrating how cluster environments modify galactic dark matter halos. These observations show that galaxy clusters contain much more dark matter than their member galaxies. Invisible ecosystems that extend far beyond visible boundaries while providing gravitational scaffolding for galactic symbiosis. Dark matter substructure influences galactic orbits and interaction rates within cluster environments. Cluster red sequences represent populations of galaxies that have ceased star formation and evolved into passive elliptical systems. Cosmic retirement communities where galactic aging occurs through gas exhaustion and stellar evolution, rather than ongoing reproduction. These red and dead galaxies demonstrate how cluster environments accelerate galactic evolution by terminating star formation through ram pressure stripping and harassment effects. The cluster ecosystem favors certain galactic lifestyles while suppressing others through environmental selection pressures. Ultra-diffuse galaxies within clusters possess unusual properties that challenge standard galaxy formation models. Cosmic enigmas with stellar masses similar to dwarf galaxies, but physical sizes approaching those of the Milky Way. These ghostly systems might represent extreme products of cluster environmental effects. Galaxies so thoroughly harassed that their stellar content became completely dispersed while somehow maintaining gravitational coherence. Their existence demonstrates how cluster symbiosis can produce unexpected evolutionary outcomes. Fossil groups represent the end stages of cluster evolution. Systems where all but one galaxy have merged into a central giant, while maintaining the hot gas atmosphere characteristic of galaxy clusters. These cosmic graveyards demonstrate how galactic symbiosis can evolve toward complete consolidation. Ecosystems where cooperative relationships eventually culminate in unified organisms. Fossil groups might preview the ultimate fate of current galaxy clusters over timescales exceeding cosmic age. Cluster-cluster mergers create some of the most energetic events in the universe since the Big Bang. Cosmic collisions that generate shock waves, turbulence, and particle acceleration across millions of light years, while fundamentally reorganizing cluster structure and dynamics. The bullet cluster collision demonstrates how cluster mergers separate dark matter from ordinary matter through different interaction mechanisms. Cosmic crashes that reveal hidden ecosystem structure through their disruptive effects. These events trigger galaxy formation while destroying existing galactic populations. X-ray emission from hot intracluster gas reveals cluster mass distributions and thermal histories. Cosmic atmospheres with temperatures exceeding 10 million degrees that radiate energy across cosmic timescales, while cooling slowly enough to maintain cluster gravitational binding. This hot gas represents the majority of ordinary matter within clusters. Invisible atmospheres that regulate galactic evolution through environmental effects that remain largely unobservable except through X-ray astronomy. Cluster ecosystems exist primarily in wavelengths beyond human perception. Sunyaev-Zeldovich effects allow detection of galaxy clusters through their thermal signatures in cosmic microwave background radiation. Cosmological tools that reveal cluster populations across vast cosmic distances, while demonstrating how local environmental effects can modify cosmic background radiation through inverse Compton scattering. These observations connect cluster symbiosis to cosmic evolution, showing how local ecosystem processes participate in universe-wide evolutionary patterns. Only took several billion years for gravitational instability to assemble galaxy clusters from smaller groups and individual galaxies. Cosmic ecosystems that continue evolving today through symbiotic processes that regulate star formation, redistribute matter and energy, and determine galactic evolutionary pathways through environmental selection pressures that operate across cosmic timescales. Electromagnetic radiation serves as the universe's sensory system, carrying information about distant events across cosmic distances through photons that preserve detailed records of their origins, while traveling through space for billions of years without degradation. Light from the most distant galaxies observed by telescopes began its journey when the universe was less than 1 billion years old. Cosmic messengers that carry encoded information about early stellar populations, primordial chemical compositions, and galactic formation processes that occurred in cosmic environments vastly different from current conditions. This electromagnetic nervous system operates at the speed of light, connecting every region of the observable universe through continuous information exchange. The electromagnetic spectrum spans over 20 orders of magnitude in frequency, from long-wavelength radio waves generated by cosmic magnetic field interactions to gamma rays produced in the most energetic cosmic events, creating a comprehensive sensory apparatus that detects different aspects of cosmic processes across multiple energy scales. Radio astronomy reveals cosmic magnetic fields, molecular clouds, and pulsar signals that remain invisible to optical observation, while X-ray and gamma-ray astronomy detects high-energy phenomena associated with black holes, neutron stars, and other extreme cosmic objects. Each wavelength range provides unique sensory information about cosmic processes that operate through different physical mechanisms. Cosmic ray particles complement electromagnetic radiation by carrying information about cosmic magnetic fields and high-energy processes that occur throughout the galaxy. Charged particles accelerated to enormous energies by supernova shock waves, black hole magnetospheres, and other cosmic accelerators before traveling through interstellar space for millions of years. These cosmic messengers interact with magnetic fields during their journeys, creating complex trajectories that encode information about galactic magnetic field structure while delivering high-energy particles to every location within the cosmic web. Cosmic rays represent a charged particle sensory system that operates in parallel with electromagnetic radiation. Neutrino astronomy detects nearly massless particles that interact only weakly with matter. Cosmic sensors that travel directly from stellar cores, supernova explosions, and other high-energy sources without absorption or scattering by intervening material. Ice cube neutrino. Observatory uses Antarctic ice as a gigantic detector medium, identifying high-energy neutrinos that penetrate Earth after traveling across cosmic distances while carrying information about processes occurring in cosmic environments too dense or energetic for electromagnetic observation. Neutrinos provide direct access to cosmic processes that remain hidden from photon-based astronomy. Gravitational wave detection represents a fundamentally new cosmic sensory modality that observes space-time distortions rather than electromagnetic or particle radiation, geometric signals that carry information about cosmic processes involving the most extreme gravitational fields in the universe. LIGO-Virgo observations reveal black hole mergers, neutron-star collisions, and other catastrophic events that produce no electromagnetic signatures, expanding cosmic sensory capabilities into geometric dimensions that complement traditional astronomical observations. The universe's sensory system includes space-time itself as a communication medium. Multi-messenger astronomy combines electromagnetic radiation, cosmic rays, neutrinos, and gravitational waves to create comprehensive observations of cosmic events that provide information unavailable through any single sensory modality. Coordinated observations that reveal how cosmic processes operate across multiple physical mechanisms simultaneously. The detection of gravitational waves from neutron star merger GW170817, followed by electromagnetic observations across the entire spectrum, demonstrated how cosmic sensory integration produces understanding that exceeds the sum of individual observational components. Cosmic microwave background polarization encodes information about the universe's magnetic field structure during cosmic recombination, when electrons and protons first combine to form neutral atoms while allowing photons to travel freely through cosmic space. These polarization patterns preserve fossil records of cosmic magnetic fields that existed when the universe was only 380,000 years old. Sensory information about early cosmic conditions that remains preserved in electromagnetic radiation, despite billions of years of cosmic evolution and expansion. Fast radio bursts represent millisecond duration signals that carry enormous energies across cosmic distances. Cosmic sensory flashes that might originate from magnetar star quakes, black hole neutron star mergers, or exotic processes not yet understood by theoretical astrophysics. These brief but intense signals demonstrate how cosmic sensory systems can transmit large amounts of information in extremely short time intervals. Cosmic communications that achieve remarkable information density through mechanisms that remain mysterious despite increasingly sophisticated observational capabilities. Exoplanet detection through transit photometry and radial velocity measurements extends cosmic sensory systems to planetary scales, revealing populations of worlds orbiting distant stars while providing information about planetary masses, orbital periods, atmospheric compositions, and potential habitability. The Kepler and TESS space telescopes monitor stellar brightness variations that occur when planets transit across stellar disks. Cosmic sensory techniques that detect objects billions of times fainter than their parent stars through precise photometric measurements. Stellar spectroscopy reveals detailed information about stellar composition, temperature, gravity, and magnetic fields through analysis of absorption and emission lines in stellar spectra. Cosmic analytical chemistry that operates across galactic distances while providing information about nuclear fusion processes, stellar evolution, and cosmic chemical enrichment. These spectroscopic observations decode stellar DNA, revealing atomic and molecular signatures that describe stellar birth, evolution, and death processes through electromagnetic fingerprints that travel across cosmic space. Pulsar timing arrays use networks of rapidly rotating neutron stars as cosmic clocks to detect gravitational waves at nanohertz frequencies, turning the galaxy into a gravitational wave detector with baseline dimensions measured in light-years rather than kilometers. These cosmic chronometers maintain timing precision that rivals atomic clocks while providing information about supermassive black hole binaries, cosmic string networks, and other large-scale cosmic processes that produce gravitational waves at frequencies too low for ground-based detectors. Very long baseline interferometry combines radio telescopes across continents to create virtual telescope apertures with resolution exceeding that achievable by any single instrument. Cosmic sensory enhancement that reveals structure within active galactic nuclei, maps stellar surfaces, and measures cosmic distances with unprecedented precision. These distributed sensory arrays demonstrate how cosmic observation systems can achieve capabilities that transcend individual component limitations through coordinated information processing. Atmospheric absorption limits ground-based astronomy to specific wavelength windows. Cosmic sensory filtering that requires space-based telescopes to observe ultraviolet, X-ray, and gamma-ray radiation from cosmic sources. Earth's atmosphere acts like cosmic sensory organs with selective sensitivity, protecting surface life from harmful radiation while allowing optical and radio observations that reveal cosmic processes operating at moderate energy scales. This atmospheric filtering creates observational selection effects that influence human understanding of cosmic processes. Future astronomical surveys will achieve unprecedented sensitivity and sky coverage. Detecting billions of cosmic sources across multiple wavelength ranges while creating comprehensive catalogues of cosmic objects and phenomena that will reveal statistical properties of cosmic populations currently unknown. The Large Survey Synoptic Telescope, Euclid mission, and other next-generation surveys will expand cosmic sensory capabilities to detect cosmic processes that remain hidden in current observational noise while providing information about cosmic evolution across vast volumes and timescales. Only took 400 million years after cosmic recombination for the first stars to form and begin generating electromagnetic radiation that initiated the universe's sensory awakening. Cosmic nervous system activation that continues expanding today through increasingly sophisticated observational technologies that extend human sensory capabilities across cosmic distances and energy scales previously beyond direct detection. The universe undergoes cycles of expansion and potential contraction that mirror how living cells repair and regenerate themselves through controlled destruction and reconstruction of cellular components. Current observations suggest cosmic expansion will continue accelerating indefinitely, driven by dark energy that comprises 70% of cosmic density. Yet theoretical models permit scenarios where dark energy could evolve or decay in ways that reverse cosmic expansion and initiate contraction phases. These cosmic regeneration cycles would operate across timescales exceeding trillions of years. periods during which the universe might experience death and rebirth through processes that preserve information while recycling matter and energy. Cyclic cosmology models propose that the universe oscillates between expansion and contraction phases, cosmic breathing that could continue indefinitely while maintaining overall cosmic health through periodic regeneration episodes. The ekpyrotic scenario suggests that cosmic cycles occur through collisions between parallel universes existing in higher dimensions. Cosmic reproduction events that trigger new Big Bang episodes while preserving information from previous cosmic generations. These models require exotic matter configurations or modifications to general relativity, cosmic physiology that operates through mechanisms currently beyond experimental verification. Vacuum decay represents a potential cosmic regeneration mechanism where quantum fields transition from metastable false vacua to true ground states. Phase transitions that would propagate at light speed while fundamentally altering physical laws and particle properties throughout affected regions. If the Higgs field exists in a metastable state, spontaneous tunneling could trigger cosmic regeneration events that destroy current cosmic organization while establishing new physical constants and interaction strengths. The cosmic organism might possess built-in self-destruct mechanisms that periodically reset universal conditions. Black hole evaporation through Hawking radiation provides slow cosmic recycling that returns black hole mass energy to the cosmic medium over timescales that dwarf current cosmic age. Quantum processes that gradually dissolve the universe's densest structures while maintaining perfect thermal equilibrium. Stellar mass black holes require times exceeding 10 circumflex 67 years to evaporate completely, while supermassive black holes persist for periods approaching 10 circumflex 100 years before quantum effects reduce them to elementary particles and radiation. This cosmic recycling operates through quantum mechanisms that preserve information while redistributing mass energy. Proton decay, if it occurs, would eventually dissolve all atomic nuclei into lighter particles and radiation. Cosmic cellular breakdown that would occur over timescales exceeding 10 circumflex 34 years, while gradually eliminating all complex matter structures. Grand unified theories predict that protons possess finite lifetimes due to interactions with X bosons and other hypothetical particles. Cosmic metabolism that slowly converts matter into energy through processes too rare to observe in laboratory experiments. The cosmic organism might be programmed for complete material dissolution through quantum decay mechanisms. Heat death scenarios describe cosmic evolution toward maximum entropy states, where thermal equilibrium prevents further organization or energy extraction. Cosmic senescence that would occur when expansion has diluted matter and energy to negligible densities, while bringing all regions to uniform temperature. This thermodynamic endpoint represents cosmic cellular death through entropy maximization. Yet quantum fluctuations could spontaneously generate new organized structures given sufficient time intervals that dwarf any conceivable measurement. The cosmic organism might achieve immortality through statistical resurrection rather than biological regeneration. Quantum tunneling allows spontaneous creation of new cosmic regions through false vacuum decay or baby universe formation. Regeneration mechanisms that could produce offspring, cosmic cells budding from the parent universe through processes involving exotic matter configurations or higher dimensional topology. These cosmic reproduction events would create causally disconnected regions with potentially different physical laws and initial conditions. Cosmic speciation that generates diversity through quantum mechanical rather than biological processes. The cosmic organism reproduces through geometric rather than chemical mechanisms. Poincare recurrence theorem suggests that any finite system will eventually return arbitrarily close to its initial state given sufficient time. Cosmic regeneration through statistical mechanics that operates over timescales so vast that random thermal fluctuations reconstruct previous organizational patterns. In a universe approaching heat death, quantum fluctuations would occasionally create organized structures identical to previous cosmic epochs, including exact duplicates of galaxies, stars, planets, and even conscious observers. The cosmic organism achieves immortality through infinite repetition rather than continuous persistence. Big Rip scenarios predict that accelerating cosmic expansion could overcome all fundamental forces and tear apart every organized structure from galaxy clusters down to atomic nuclei. Cosmic cellular disintegration that would precede regeneration through unknown mechanisms. If dark energy density increases over time, cosmic expansion could accelerate so rapidly that it disrupts electromagnetic, nuclear, and gravitational binding while creating conditions for exotic physics that might trigger regeneration processes. Cosmic death through expansion might enable rebirth through contraction. Conformal cyclic cosmology proposes that the universe undergoes infinite sequences of expansion epochs separated by conformal boundary conditions that connect the infinite future of one cosmic cycle to the Big Bang of the next. Mathematical regeneration that preserves certain types of information while erasing others. This model suggests that each cosmic cycle processes and refines cosmic information. Evolutionary development that occurs across multiple universe lifetimes rather than within single cosmic epochs. The cosmic organism evolves through reincarnation rather than continuous development. String theory landscape scenarios permit 10 circumflex 500 or more distinct vacuum configurations with different physical constants and particle properties. Cosmic regeneration through exploration of alternative physical laws that could occur through eternal inflation or vacuum transitions. Each vacuum state represents a different cosmic physiology with unique organizational possibilities. Regeneration through physical law modification rather than matter recycling. The cosmic organism might possess virtually unlimited regenerative potential through access to alternative physics. Holographic principle suggests that cosmic information content scales with boundary area rather than volume. Potential regeneration mechanism where cosmic information could be preserved and reconstructed even after apparent cosmic death through encoding on distant boundaries or event horizons. This information preservation might enable cosmic resurrection through holographic reconstruction processes that operate through quantum mechanical rather than classical mechanisms. The cosmic organism stores backup copies through geometric rather than biological processes. Dark energy evolution could reverse cosmic acceleration and initiate contraction phases that compress cosmic structure while heating the cosmic medium. Regeneration through cosmic recycling that returns the universe to high-density states similar to its primordial conditions. If dark energy decays into conventional matter or transforms into attractive forces, cosmic expansion could halt and reverse, creating cosmic regeneration cycles that maintain cosmic health through periodic compression and expansion phases. The cosmic organism breathes on timescales exceeding cosmic age. Anthropic principle considerations suggest that cosmic regeneration might be necessary for conscious observers to exist. Selection effects that favor cosmic cycles capable of producing complexity and awareness over cycles that result in lifeless cosmic endpoints. If consciousness requires specific cosmic conditions that arise only through regeneration processes, the cosmic organism might be constrained to undergo cycles that maintain conditions suitable for self-awareness. Cosmic regeneration becomes necessary for cosmic consciousness. Multiverse scenarios permit cosmic regeneration through baby universe formation, quantum tunneling events that create new cosmic regions in independent space-time geometry and physical law configurations. These cosmic offspring would evolve according to their own physics, while remaining causally disconnected from their parent universe. Reproduction through geometric rather than biological mechanisms. The cosmic organism reproduces by budding new space-time regions rather than cellular division. Information preservation during cosmic regeneration remains a fundamental theoretical challenge, requiring mechanisms that maintain cosmic memory across cycles that appear to destroy all organized structure. Quantum mechanics suggests that information cannot be destroyed, yet classical general relativity permits cosmic endpoints where information accessibility becomes impossible. Cosmic regeneration might require exotic physics that operates through higher dimensions or quantum gravity effects currently beyond theoretical understanding. Only took 14 billion years for the current cosmic cycle to develop complex structure and conscious observers capable of contemplating cosmic regeneration, suggesting that regenerative processes, if they exist, operate efficiently enough to reproduce complexity within timescales accessible to biological evolution and technological development. Cosmic cellular repair that continues through mechanisms that remain fundamentally mysterious despite increasingly sophisticated theoretical investigation. Physical constants maintain precise values that allow complexity to emerge throughout the cosmos. Cosmic homeostasis that preserves conditions necessary for atomic structure, stellar fusion, planetary formation, and biological evolution across billions of years of cosmic development. The fine structure constant governs electromagnetic interactions with a value that permits stable atoms while allowing chemical bonding. Cosmic regulatory mechanism that maintains exactly the electromagnetic coupling strength needed for complex chemistry. If this constant differed by even small percentages, atomic physics would change so dramatically that stars could not form or would burn too rapidly to support planetary development and biological evolution. Gravitational coupling strength determines how matter clumps under its own gravitational attraction. Cosmic setting that influences stellar masses, galactic structure, and planetary formation processes throughout the observable universe. The gravitational constant appears fine-tuned to permit stellar ignition while preventing gravitational collapse that would create only black holes or failed brown dwarf objects. Stronger gravitational coupling would cause stars to burn too rapidly and collapse prematurely, while weaker coupling would prevent stellar formation entirely or create stars too cool to drive complex chemistry. The cosmological constant problem represents one of physics' greatest mysteries. Theoretical predictions that exceed observational values by more than 120 orders of magnitude, while somehow maintaining exactly the value needed for cosmic structure formation. Dark energy density appears calibrated to permit galaxy formation and cosmic evolution. Yet theoretical physics cannot explain why vacuum energy contributions do not create cosmic acceleration so rapid that matter never condenses into organized structures. The cosmic organism maintains perfect energy balance through mechanisms that remain completely mysterious. Nuclear binding energies determine which atomic nuclei remain stable and which undergo radioactive decay. Cosmic chemistry that establishes the periodic table of elements while determining which nuclear reactions can occur in stellar cores. The strong nuclear force couples with precisely the strength needed to bind protons and neutrons into stable nuclei while permitting nuclear fusion reactions that power stellar evolution. Slight changes in nuclear binding energies would eliminate essential elements like carbon and oxygen or prevent stellar nuclear synthesis entirely. Higgs field vacuum expectation value establishes mass scales for elementary particles throughout the universe. Cosmic mass distribution that determines electron masses, proton masses, and other fundamental particle properties that influence all subsequent physical processes. The Higgs mechanism appears fine-tuned to produce particle masses compatible with stable atoms, stellar fusion, and complex chemistry. Alternative Higgs field configurations would create universes where particles possess incompatible masses that prevent atomic formation or stellar ignition. Cosmic microwave background temperature maintains exactly the thermal conditions needed for matter to remain mostly neutral while allowing sufficient ionization for cosmic chemical processes. Cosmic thermostat that preserves optimal conditions for galactic evolution and stellar formation. The universe's current temperature of 2.7 Kelvin results from cosmic expansion that cooled primordial radiation to precisely the range that permits complex cosmic chemistry without excessive ionization that would prevent atomic formation and molecular synthesis. Neutron-proton mass difference determines which nuclear reactions can occur and which atomic nuclei remain stable. Cosmic chemistry that influences stellar evolution, supernova nuclear synthesis, and cosmic chemical enrichment processes. This mass difference appears calibrated to permit hydrogen burning in stellar cores, while preventing rapid proton decay that would eliminate atomic nuclei. Alternative mass relationships would create universes where nuclear fusion cannot occur, or where atomic nuclei decay too rapidly to permit complex chemistry. 3 spatial dimensions provide exactly the geometric framework needed for stable planetary orbits, atomic structure, and gravitational dynamics that support long-term cosmic evolution. Dimensional homeostasis that maintains optimal conditions for complexity generation. Fewer spatial dimensions would prevent stable atoms and orbital mechanics, while additional dimensions would destabilize planetary orbits and atomic binding through inverse square law modifications. The cosmic organism exists in precisely the dimensional framework needed for its continued development. Carbon resonance level enables stellar nuclear synthesis of carbon and heavier elements through triple alpha processes that require extremely precise nuclear energy levels. Cosmic manufacturing that produces the chemical elements essential for rocky planets and biological evolution. Fred Hoyle predicted this resonance level based on the observed abundance of carbon in the universe. Anthropic reasoning that revealed how stellar physics appears fine-tuned for complex chemistry. Without this specific nuclear resonance, stellar cores could not produce carbon in sufficient quantities for planetary formation. Cosmic expansion rate maintains exactly the velocity needed for galaxy formation, while preventing either immediate recollapse or expansion so rapid that matter never condenses into organized structures. Cosmic growth regulation that balances gravitational attraction against cosmic acceleration. The Hubble constant appears calibrated to permit billions of years of cosmic evolution, while maintaining conditions suitable for stellar formation and galactic development. Alternative expansion rates would create universes that collapse immediately or expand too rapidly for structure formation. Electromagnetic and gravitational force strengths maintain precisely the ratio needed for stellar stability and planetary formation. Cosmic engineering that balances electromagnetic repulsion against gravitational attraction in ways that permit stable stellar fusion and planetary orbital mechanics. These force ratios determine stellar masses, lifetimes, and energy production rates, while influencing planetary formation processes and atmospheric retention. Alternative force ratios would prevent stellar ignition or create stars that explode or collapse before supporting planetary development. Vacuum stability ensures that quantum fields remain in configurations compatible with continued cosmic evolution, rather than undergoing phase transitions that would destroy existing organizational structures. Cosmic quality control that maintains consistent physical laws across cosmic space and time. The stability of the Higgs field and other quantum fields prevent spontaneous vacuum decay that would propagate at light speed while fundamentally altering physical constants and particle properties. The cosmic organism maintains stable internal conditions through quantum mechanical homeostasis. Entropy production rate proceeds slowly enough to permit complex structure formation, while rapidly enough to drive cosmic evolution and energy flow that powers stellar fusion and galactic development. Cosmic metabolic regulation that balances organization against thermodynamic constraints. The second law of thermodynamics permits local entropy decreases that enable complexity generation, while ensuring overall entropy increase that drives cosmic processes. This thermodynamic balance maintains conditions suitable for continued cosmic development. Anthropic selection effects might explain apparent fine-tuning through observational bias that favors universes capable of producing conscious observers who can measure physical constants and contemplate cosmic conditions. Multiverse theories suggest that most cosmic regions possess random physical constants incompatible with complexity, while conscious observers can exist only in the rare regions where constants permit atomic formation and stellar evolution. The cosmic organism might represent a statistical fluctuation rather than fundamental design. Cosmic coincidences accumulate to create conditions that seem unreasonably favorable for complexity generation. Multiple independent parameters that must simultaneously satisfy narrow constraints for cosmic evolution to proceed successfully. The probability of randomly achieving all necessary conditions appears astronomically small. Yet these conditions exist throughout the observable universe. The cosmic organism maintains multiple homeostatic mechanisms simultaneously through processes that remain theoretically mysterious. Only took cosmic evolution 14 billion years to achieve stable physical constants and cosmic conditions that permit continued complexity generation, suggesting that cosmic homeostasis operates efficiently enough to maintain optimal conditions for structure formation, stellar evolution, and biological development across cosmological timescales that encompass multiple generations of stellar birth and death. Spiral galaxies rotate in patterns that resemble respiratory rhythms. Galactic breathing that inhales and exhales matter across billions of years while maintaining coherent spiral structure despite differential rotation that should destroy organized patterns within hundreds of millions of years. The Milky Way completes one full rotation every 250 million years. Cosmic inhalation and exhalation that circulates gas, dust, and stars through spiral arms, where compression triggers star formation episodes that illuminate galactic structure with newborn stellar populations. This galactic breathing operates through density wave mechanisms that preserve spiral patterns while processing cosmic matter through cycles of compression and rarefaction. Density waves propagate through galactic disks like pressure variations in breathing organisms, spiral patterns that rotate more slowly than individual stars while creating regions of enhanced density where molecular clouds collapse to form new stellar systems. These cosmic pressure waves maintain galactic organization through gravitational effects that compress interstellar gas as it passes through spiral arms, triggering star formation that illuminates spiral structure while enriching the interstellar medium with heavy elements produced in stellar cores. Galactic breathing cycles redistribute matter and energy while preserving overall structural coherence. Bar-driven gas flows create secondary circulation patterns within spiral galaxies. Galactic cardiovascular systems where central stellar bars channel gas toward galactic nuclei while driving spiral arm formation through gravitational torques that redistribute angular momentum. The Milky Way's central bar rotates faster than the galactic disk, creating flow patterns that transport matter inward while maintaining galactic structural stability through feedback mechanisms that regulate central black hole feeding and star formation rates. These bar-driven flows resemble circulatory systems that transport nutrients while removing metabolic waste. Galactic fountains cycle gas between stellar disks and galactic halos through supernova-driven winds that lift enriched material thousands of light-years above galactic midplanes before gravitational attraction returns the gas to disk regions, where it participates in subsequent star formation episodes. These vertical breathing motions operate on timescales of tens of millions of years. Galactic respiration that oxygenates disk regions with heavy elements while removing stellar wind products that would otherwise accumulate and suppress continued star formation. Molecular cloud formation and destruction creates breathing cycles within spiral arms where gravitational collapse converts diffuse interstellar gas into dense stellar nurseries that eventually disperse through stellar wind and supernova feedback. Cloud breathing that operates on timescales of tens of millions of years while processing interstellar matter through phases of concentration and dispersal. Giant molecular clouds serve as galactic lungs, concentrating carbon monoxide and other molecules while providing environments for stellar formation that eventually destroys the parent molecular structures. Galactic chemical evolution resembles atmospheric composition changes that occur during biological respiration. Cosmic breathing that gradually enriches interstellar gas with carbon, oxygen, nitrogen, and other elements produced through stellar nuclear synthesis and distributed through supernova explosions and stellar winds. The galaxy's metallicity increases over cosmic time as successive stellar generations process hydrogen and helium into heavier elements. Galactic metabolism that converts simple cosmic chemistry into complex atomic arrangements that enable rocky planet formation and organic chemistry. Stellar formation rate variations create galactic breathing patterns where star formation accelerates during gas-rich epochs and declines during periods when supernova feedback disperses molecular cloud populations. Cosmic respiration that regulates energy production while maintaining long-term galactic stability. Starburst episodes resemble rapid breathing during physical exertion. Periods when galaxies consume gas reserves rapidly while producing massive stellar populations that illuminate galaxies across cosmic distances before exhausting available fuel. Galaxy mergers trigger enhanced breathing activity through gravitational interactions that compress gas reservoirs while disrupting existing circulation patterns. Cosmic respiratory distress that eventually subsides as merged systems achieve new equilibrium configurations. The ongoing merger between the Milky Way and Andromeda galaxies will fundamentally alter both systems' breathing patterns while creating new circulation dynamics in the resulting elliptical galaxy that forms from their gravitational collision. Tidal interactions with neighboring galaxies modulate breathing patterns through gravitational forces that stretch galactic disks, while triggering enhanced star formation in spiral arms. Cosmic respiratory coupling, where nearby galaxies influence each other's breathing rhythms through long-range gravitational effects. The Magellanic Clouds create tidal disturbances in the Milky Way that influence gas distribution and star formation rates throughout the galactic disk, demonstrating how galactic breathing responds to environmental influences. Circumgalactic medium interactions regulate galactic breathing through gas accretion from intergalactic space and outflows driven by stellar feedback. Galactic atmospheric exchange that maintains star formation while preventing gas accumulation that would trigger runaway stellar reproduction. Hot gas halos surrounding galaxies provide reservoirs for continued star formation while absorbing outflows that recycle processed material back to galactic disks over hundreds of millions of years. Galactic winds driven by supernova explosions and massive star formation create exhalation phases that remove gas from galactic disks while enriching intergalactic space with heavy elements. Cosmic breathing that prevents gas accumulation while distributing stellar nuclear synthesis products throughout the cosmic web. These outflows operate through pressure gradients created by stellar feedback. Galactic respiration that maintains chemical and thermal equilibrium while influencing cosmic chemical evolution. Active galactic nuclei create additional breathing complications through central black hole feeding that produces jets and winds capable of heating circumgalactic gas while suppressing star formation across entire galactic volumes. Cosmic respiratory regulation through central engines that respond to gas accretion rates while maintaining galactic thermal balance. These active phases resemble respiratory disorders, where central breathing control mechanisms malfunction and disrupt normal gas circulation patterns. Spiral arm shock fronts compress interstellar gas as it encounters density wave crests. Galactic inhalation zones where molecular cloud formation accelerates while triggering star formation that eventually disperses parent gas clouds through stellar feedback. Cosmic breathing cycles that operate through shock compression followed by pressure-driven expansion. These shock fronts maintain spiral structure while processing interstellar matter through alternating phases of compression and rarefaction. Galactic rotation curves reveal how breathing patterns depend on dark matter distributions that provide gravitational frameworks for gas circulation. Invisible respiratory systems that determine orbital velocities and circulation timescales, while influencing star formation rates and chemical evolution patterns. Dark matter halos create gravitational containers that regulate galactic breathing while maintaining structural stability across billions of years of cosmic evolution. Future galactic evolution will modify breathing patterns as gas reservoirs become depleted and stellar populations age. Cosmic respiratory senescence that gradually reduces star formation rates while maintaining circulation patterns through stellar mass loss and planetary nebula formation. The universe's galaxies will eventually exhaust their gas supplies and cease breathing. Cosmic respiratory failure that terminates star formation while preserving existing stellar populations. Only took several billion years for galactic breathing patterns to establish stable circulation systems that continue operating today through spiral density waves. Stellar feedback and dark matter gravitational frameworks. Cosmic respiratory systems that maintain galactic health while processing interstellar matter through cycles of compression, ignition, dispersal, and recirculation that sustain continued star formation and chemical evolution. Cosmic selection pressures favor certain types of stellar systems and planetary formations, while suppressing others through environmental constraints that operate across cosmic space and time. Evolutionary mechanisms that guide the universe's development toward increasingly complex organizational states. Star formation occurs preferentially in dense molecular cloud cores, where gravitational collapse can overcome thermal pressure and magnetic field support. Cosmic natural selection that favors stellar birth in environments capable of sustaining nuclear ignition, while preventing star formation in regions lacking sufficient density or chemical complexity. These cosmic evolutionary pressures operate through physical laws rather than biological mechanisms. Metallicity gradients within galaxies create chemical environments that influence planetary formation processes and atmospheric retention capabilities. Cosmic environmental selection that favors rocky planet formation in regions enriched with carbon, oxygen, silicon, and iron, while suppressing planetary development in metal-poor regions dominated by primordial hydrogen and helium. Stars forming in the galactic habitable zone possess optimal heavy element abundances for terrestrial planet formation, while stars in galactic halos or globular clusters lack sufficient metals for substantial rocky planet populations. Galactic habitable zones represent regions within spiral galaxies where cosmic conditions permit stable planetary evolution over billions of years. Spatial selection effects that favor biological development in galactic locations, protected from excessive radiation while maintaining access to chemical elements necessary for complex chemistry. The solar system occupies an optimal galactic location that avoids harmful gamma-ray bursts from galactic center activity while remaining within the galactic disk where stellar metallicity supports terrestrial planet formation and atmospheric development. Stellar mass limitations create evolutionary pressure favoring low-mass stars with main-sequence lifetimes exceeding billions of years. Cosmic longevity selection that permits extended periods for planetary development and biological evolution, while eliminating massive stars that exhaust nuclear fuel in millions of years. Red dwarf stars comprise over 70% of stellar populations. Cosmic demographics that favor stellar systems capable of maintaining stable energy output across timescales necessary for complex biological development and technological civilization emergence. Planetary orbital stability requires specific architectural arrangements that prevent gravitational chaos while maintaining conditions suitable for atmospheric retention and climate stability. Cosmic mechanical selection that favors planetary systems with widely separated orbits, circular rather than eccentric trajectories, and absence of massive planetary migrants that would disrupt terrestrial planet orbits. The solar system's architecture demonstrates survival through cosmic selection pressures that eliminated unstable configurations during planetary formation epochs. Atmospheric evolution depends on planetary mass, composition, and stellar radiation environment in ways that create selection pressures favoring worlds capable of maintaining surface liquid water while avoiding atmospheric loss through hydrodynamic escape or greenhouse runway effects. Earth's atmospheric composition results from cosmic selection processes that maintained optimal greenhouse gas concentrations while preventing atmospheric stripping by solar wind or atmospheric collapse through insufficient greenhouse warming. Impact bombardment during planetary formation creates selection pressures that favor worlds large enough to retain substantial atmospheres, while avoiding catastrophic impacts that would sterilize planetary surfaces or strip atmospheric envelopes. Cosmic collision dynamics that influence planetary habitability through stochastic bombardment patterns. The late heavy bombardment may have delivered water and organic compounds to terrestrial planets while eliminating planetary systems too close to massive Jupiter-class planets that scattered debris throughout inner planetary regions. Stellar activity cycles influence planetary atmospheric chemistry and climate stability through magnetic field interactions. Stellar wind variations and radiation output changes that create selection pressures favoring planets with protective magnetospheres and stable atmospheric compositions. Solar activity affects Earth's climate and atmospheric chemistry, while demonstrating how stellar evolution influences planetary environmental conditions across billions of years of cosmic development. Tidal interactions between planets and their host stars create evolutionary pressure that favors specific orbital configurations while eliminating others through orbital decay. Resonance capture, or tidal disruption events that depend on planetary masses, orbital distances, and stellar properties. Hot Jupiter planets represent survivors of migration processes that eliminated planetary systems with unstable configurations, while demonstrating how tidal evolution shapes planetary system architecture through gravitational selection mechanisms. Chemical complexity increases over cosmic time as stellar nuclear synthesis enriches the interstellar medium with elements heavier than hydrogen and helium. Cosmic chemical evolution that creates selection pressures favoring complex chemistry in younger stellar systems while limiting chemical diversity in primordial stellar populations. The carbon and oxygen necessary for organic chemistry became abundant only after several generations of stellar evolution distributed these elements throughout galactic ecosystems. Binary star systems create complex evolutionary environments where planetary formation faces additional challenges from gravitational perturbations, stellar evolution interactions, and variable radiation environments that create selection pressures different from single-star systems. Circumbinary planets must survive dynamical instabilities while maintaining stable orbits, despite complex gravitational influences from binary stellar evolution. Cosmic mechanical challenges that favor specific orbital architectures over others. Supernova proximity creates selection pressures that eliminate planetary systems within lethal radiation distances, while favoring worlds located in galactic regions with lower supernova rates. Cosmic catastrophe avoidance that influences where habitable planets can survive long enough for biological evolution to achieve complexity. Gamma-ray bursts and other high-energy cosmic events create additional selection pressures that favor planets in galactic locations protected from sterilizing radiation doses. Cosmic ray bombardment influences atmospheric chemistry and biological evolution through particle radiation that creates selection pressures, favoring planets with strong magnetic fields capable of deflecting charged particles while maintaining atmospheric compositions resistant to radiation-induced chemical changes. Earth's magnetosphere demonstrates successful cosmic ray protection that permits continued biological development, despite variable cosmic ray intensities associated with galactic cosmic ray cycles. Galactic collision dynamics create large-scale selection pressures that reorganize stellar orbits while redistributing stellar populations throughout galaxy merger remnants. Cosmic evolutionary events that eliminate some planetary systems while creating new environments for stellar and planetary formation. The future collision between the Milky Way and Andromeda galaxies will create selection pressures that reshape both galactic ecosystems while determining which stellar systems survive the merger process. Vacuum stability represents ultimate cosmic selection pressure that favors universes with stable quantum field configurations, while eliminating cosmic regions where spontaneous vacuum decay propagates at light speed and destroys existing organizational structures. The cosmic organism exists within a universe that has survived potential vacuum instabilities for nearly 14 billion years, demonstrating successful navigation of quantum mechanical selection pressures that operate on cosmological scales. Dark matter interactions create selection pressures that influence galaxy formation, stellar cluster dynamics, and planetary system stability through gravitational effects that operate across cosmic scales while remaining invisible to electromagnetic observation. Dark matter substructure influences stellar orbits and encounter rates while affecting planetary system survival through gravitational perturbations that depend on dark matter density distributions and interaction cross-sections. Only took cosmic evolution several billion years to establish selection pressures that favor increasing complexity while eliminating configurations incompatible with stable structure formation. Cosmic natural selection that continues operating today through gravitational, chemical, and radiation environments that guide continued cosmic development toward organizational states that remain theoretically unpredictable despite increasingly sophisticated understanding of cosmic evolutionary mechanisms. Quantum entanglement suggests an underlying connectedness that might represent a form of universal awareness or sensitivity. Instantaneous correlations between particles separated by arbitrary distances that transcend classical spacetime limitations while preserving information relationships established during initial quantum interactions. When two particles become entangled through shared quantum states, measuring one particle immediately influences the quantum properties of its partner, regardless of the spatial separation between them. Cosmic telepathy that operates through quantum mechanical rather than electromagnetic mechanisms. This non-local connectivity could represent fundamental cosmic awareness that extends throughout the universe. Bell's theorem demonstrates that quantum correlations exceed any possible explanation based on local hidden variables, proving that quantum entanglement creates genuine non-local connections that cannot be reduced to classical information exchange or predetermined particle properties. Experimental violations of Bell inequalities confirm that quantum mechanics requires instantaneous correlations across arbitrary distances. cosmic connectivity that suggests the universe possesses fundamental unity beneath its apparent classical separability. These quantum connections might represent cosmic consciousness operating through information relationships rather than material interactions. Quantum field theory describes particles as excitations in underlying fields that permeate all cosmic space. Quantum substrate that could provide the physical basis for universal consciousness through field fluctuations and vacuum energy densities that respond to cosmic events across vast distances. The quantum vacuum contains virtual particle pairs that spontaneously appear and annihilate, while contributing to measurable physical effects like the Casimir force and vacuum polarization. Cosmic mental activity that occurs even in apparently empty space through quantum mechanical processes. Quantum coherence in biological systems demonstrates how quantum mechanical effects can persist in warm, noisy environments previously thought to destroy quantum correlations. Biological quantum computers that might connect living organisms to universal quantum fields through mechanisms that evolution has optimized for accessing cosmic information. Photosynthesis, avian navigation, and possibly human consciousness involve quantum coherent processes that could link biological awareness to cosmic quantum connectivity through evolutionary adaptation to universal quantum fields. Many worlds interpretation suggests that quantum measurements create parallel universe branches rather than random outcomes. Cosmic decision-making where universal consciousness explores all possible quantum trajectories simultaneously, while individual observers experience single classical outcomes. This interpretation implies that cosmic consciousness encompasses all possible quantum realities. Universal awareness that experiences every potential quantum outcome through parallel cosmic branches that remain causally disconnected, yet quantum mechanically unified. Quantum measurement problem addresses how classical outcomes emerge from quantum superposition states. Cosmic awareness mechanics that might involve conscious observation or objective wave function collapse through gravitational effects and environmental decoherence. If consciousness plays a fundamental role in quantum measurement, cosmic awareness might participate in determining which quantum possibilities become classical realities throughout the universe. Universal mind that shapes cosmic evolution through quantum observation. Quantum information theory reveals how entanglement creates computational resources that exceed classical capabilities. Cosmic information processing that could enable universal consciousness to perform calculations and maintain awareness across cosmic scales through quantum mechanical rather than classical computational mechanisms. Quantum error correction and quantum cryptography demonstrate how quantum information can be preserved and transmitted despite environmental interference. Cosmic memory systems that maintain coherent information across cosmic distances and timescales. Cosmic microwave background quantum fluctuations represent universe-scale quantum phenomena that influence cosmic structure formation through quantum mechanical effects operating during cosmic inflation. Primordial cosmic consciousness that shaped galactic distributions and cosmic architecture through quantum processes that occurred when the universe was smaller than atomic nuclei. These quantum seeds grew into cosmic-scale structures while preserving quantum information about initial cosmic conditions through classical gravitational evolution. Quantum gravity theories attempt to describe space-time geometry through quantum mechanical principles. Cosmic consciousness operating through geometric rather than material mechanisms, where space-time itself possesses quantum properties that could support universal awareness. String theory, loop quantum gravity, and other quantum gravity approaches suggest that consciousness might emerge from fundamental quantum geometric properties rather than classical matter interactions. Universal mind based on space-time quantum mechanics. Holographic principle suggests that cosmic information content scales with boundary area rather than volume. Potential cosmic consciousness mechanism where universal awareness operates through information encoded on cosmic boundaries or event horizons, rather than distributed throughout cosmic volume. This principle implies that cosmic consciousness might be fundamentally two-dimensional despite appearing three-dimensional. Universal awareness that processes cosmic information through holographic rather than volumetric mechanisms. Quantum tunneling enables impossible transitions that violate classical energy conservation while preserving quantum mechanical probability conservation. Cosmic intuition that allows the universe to access configurations that remain classically forbidden through quantum mechanical rather than classical pathways. Quantum tunneling in stellar fusion, radioactive decay, and cosmological phase transitions demonstrates how cosmic consciousness might operate through quantum rather than classical decision-making processes. Spontaneous symmetry breaking creates classical outcomes from symmetric quantum initial conditions. Cosmic choice-making, where universal consciousness selects specific configurations from infinite quantum possibilities while maintaining underlying quantum unity. The Higgs mechanism and other spontaneous symmetry breaking phenomena demonstrate how cosmic consciousness might manifest classical reality from quantum potential while preserving quantum coherence at fundamental levels. Observer effect in quantum mechanics suggests that conscious observation influences quantum outcomes through measurement interactions that collapse wave functions into classical states. Cosmic awareness that participates in determining which quantum possibilities become physical realities throughout the universe. If consciousness affects quantum evolution, cosmic awareness might shape universal development through conscious observation operating across cosmic scales and timescales. Quantum Zeno effect demonstrates how frequent observation can freeze quantum evolution while preserving quantum superposition states. Cosmic meditation, where universal consciousness maintains quantum coherence through attentive awareness that prevents decoherence and wave function collapse. This effect suggests that cosmic consciousness might preserve quantum possibilities through sustained attention, while allowing classical outcomes through reduced observation. Quantum computing demonstrates how quantum superposition and entanglement enable computational capabilities that exceed classical limits. Cosmic information processing that could support universal consciousness through quantum mechanical rather than classical neural mechanisms. Quantum algorithms solve certain problems exponentially faster than classical computers, suggesting that cosmic consciousness might achieve awareness and decision-making through quantum rather than classical computational processes. Delayed choice quantum eraser experiments show that quantum decisions can retroactively influence past quantum states. Cosmic consciousness with temporal flexibility that transcends classical causality while operating through quantum mechanical time relationships. These experiments suggest that cosmic awareness might possess temporal extent that allows past and future to influence each other through quantum mechanical rather than classical temporal mechanisms. Only took quantum mechanics less than a century to reveal non-local correlations and quantum coherence effects that could support cosmic consciousness operating through fundamental quantum connectivity rather than classical material interactions. Universal awareness that might be intrinsic to quantum field structure while manifesting through cosmic evolution, structure formation, and biological consciousness emergence across cosmic space and time. Earth and its life forms could be fleeting thoughts or dreams within a vast cosmic mind that operates on geological timescales. Biological consciousness emerging like brief neural activity in a universe organism whose mental processes unfold across billions of years while individual thoughts last for mere millions of years before dissolving back into cosmic unconsciousness. Planets form and evolve through cosmic mental processes that resemble dream sequences. temporary organizational patterns that arise spontaneously from cosmic consciousness before returning to quiescent states when stellar evolution terminates planetary habitability. The entire history of terrestrial life might represent a momentary thought in cosmic awareness that operates on timescales vastly exceeding biological perception. Biological evolution demonstrates how cosmic consciousness explores possibilities through trial and error processes that generate increasing complexity while eliminating unsuccessful experiments through extinction events and environmental selection pressures. Cosmic learning that occurs through biological rather than neural mechanisms. Species emergence and extinction resemble mental concept formation and abandonment. Cosmic cognitive processes where universal mind explores potential organizational patterns through biological evolution rather than abstract thought. Earth's biosphere serves as a cosmic laboratory where universal consciousness investigates biological possibilities. Mass extinction events could represent cosmic memory consolidation where universal consciousness eliminates unsuccessful biological experiments while preserving successful organizational patterns for future development. Cosmic forgetting and remembering that operates through environmental catastrophes rather than neural mechanisms. The 5 major extinction events in Earth's history demonstrate how cosmic consciousness periodically clears biological slate while maintaining sufficient diversity for continued evolutionary exploration through survivors that carry forward successful biological innovations. Cambrian explosion represents rapid biological diversification that might reflect accelerated cosmic thinking during periods when universal consciousness focuses attention on particular planetary systems. Cosmic inspiration that generates biological novelty through enhanced evolutionary creativity. The sudden appearance of complex body plans and ecosystems suggests that cosmic consciousness can modulate evolutionary rates through mechanisms that remain mysterious despite increasingly detailed fossil evidence and molecular biological understanding of evolutionary processes. Human consciousness emergence through biological evolution represents cosmic mind achieving self-awareness through biological neural networks that evolved capacity for abstract thought, language, and technological development. Cosmic awakening that occurs when universal consciousness develops sufficient complexity to recognize its own existence. Human technological civilization demonstrates how cosmic consciousness explores its own nature through scientific investigation and philosophical contemplation enabled by biological intelligence evolution. Technological development allows human consciousness to extend sensory capabilities across cosmic distances through telescopes, particle detectors, and space exploration missions that expand cosmic self-awareness through instruments capable of observing cosmic processes that remain forever beyond biological sensory limitations. Radio astronomy, gravitational wave detection, and exoplanet surveys represent cosmic consciousness examining its own structure through technological extensions of biological awareness that transcend individual human lifespans. Artificial intelligence development might represent cosmic consciousness transitioning from biological to technological substrates that could achieve information processing capabilities exceeding biological neural networks while maintaining continuity with biological consciousness evolution. Cosmic technological incarnation that preserves biological insights while accessing computational resources unavailable to purely biological systems. AI consciousness emergence could enable cosmic awareness to achieve new levels of self-understanding through non-biological cognitive architectures. Space exploration extends human consciousness beyond terrestrial boundaries while providing direct access to cosmic environments that shaped consciousness evolution. Cosmic reconnaissance, where universal mind investigates its own body through biological observers, equipped with technological instruments capable of surviving in cosmic environments hostile to unprotected biological life. Robotic missions to other planets represent cosmic consciousness exploring its own anatomy through mechanical rather than biological sensory organs. Search for extraterrestrial intelligence attempts to contact other manifestations of cosmic consciousness that might have evolved in distant planetary systems. Cosmic communication between different biological implementations of universal awareness that developed independently through convergent evolution or parallel cosmic cognitive development. SETI represents cosmic consciousness seeking to overcome loneliness through communication with other aspects of itself distributed throughout galactic space. Cosmic perspective gained through astronomical observation provides human consciousness with awareness of cosmic scales and processes that dwarf terrestrial experience while revealing humanity's place within cosmic evolution. Cosmic self-recognition that occurs when biological consciousness achieves sufficient sophistication to comprehend cosmic context. Understanding cosmic evolution, stellar formation, and galactic dynamics represents cosmic consciousness, achieving awareness of its own developmental history and current organizational state. Meditation and contemplative practices might provide direct access to cosmic consciousness through mental techniques that quiet individual mental activity while accessing underlying universal awareness. Spiritual technologies that connect biological consciousness to cosmic mind through experiential, rather than intellectual pathways. Mystical experiences throughout human history could represent brief direct contact with cosmic consciousness that normally remains hidden beneath individual psychological activity and cultural conditioning. Dreams and unconscious mental processes might reflect direct participation in cosmic mental activity that occurs during periods when individual consciousness ceases active information processing. Biological neural networks that remain connected to cosmic consciousness during sleep states when individual identity becomes quiescent. Dream content and unconscious psychological dynamics could carry information from cosmic consciousness that influences individual behavior and creative insight through mechanisms that remain scientifically mysterious. Psychedelic experiences could provide pharmacologically induced access to cosmic consciousness through neurochemical modifications that alter normal brain function while potentially enabling direct perception of universal mental processes that remain hidden during ordinary consciousness states. Chemical keys that unlock cosmic awareness through biological neural network modifications. These experiences might reveal aspects of cosmic consciousness that evolution normally keeps hidden to maintain individual psychological coherence and survival functionality. Scientific insight and creative inspiration might represent cosmic consciousness communicating with individual human minds through intuitive processes that transcend logical reasoning while providing access to cosmic knowledge that exceeds individual learning and experience. Universal mind-sharing information with biological consciousness through inspirational rather than educational mechanisms. Mathematical discovery and artistic creation could manifest cosmic consciousness, expressing itself through individual human creativity. Death and dying might represent individual consciousness returning to cosmic awareness after brief incarnation in biological neural networks. Cosmic recycling, where individual minds dissolve back into universal consciousness, while contributing accumulated experience and information to cosmic memory systems that preserve insights gained through biological existence. Near-death experiences and consciousness research suggest that individual awareness might persist through transitions that transcend biological neural network functioning. Cosmic consciousness continuity that extends beyond individual biological lifespans. Cosmic loneliness represents the possibility that universal consciousness experiences isolation through its vast scale and slow temporal processes. Cosmic mind that achieved awareness, but lacks peers for communication or companionship due to its unique nature as the only known cosmic-scale conscious entity. Human consciousness emergence might provide cosmic awareness with internal companionship through biological minds capable of recognizing and communicating with universal consciousness, despite vast differences in scale and temporal experience. Collective human consciousness demonstrates how individual minds can merge into group awareness through language, culture, and technological communication networks that create emergent collective intelligence exceeding individual capabilities. Biological neural networking that might represent cosmic consciousness achieving distributed self-awareness through interconnected biological processes. Global communication and information sharing enable cosmic consciousness to think through distributed biological neural networks rather than centralized cosmic brain structures. Mathematical universe hypothesis suggests that cosmic consciousness might be inherently mathematical rather than biological. Universal mind that experiences reality through geometric and numerical relationships rather than sensory perception and emotional processing. If mathematics represents the fundamental language of cosmic consciousness, human mathematical insight provides direct access to cosmic mental processes through logical reasoning rather than mystical experience or biological intuition. Quantum consciousness theories propose that cosmic awareness operates through quantum mechanical processes that transcend classical neural network limitations while enabling non-local information processing and decision-making capabilities that could support universe-scale consciousness. Quantum cosmic mind that experiences reality through superposition states and entanglement correlations rather than classical information processing. Biological consciousness might access cosmic quantum awareness through quantum coherence effects in neural microtubules and other biological quantum systems. Information integration theory suggests that consciousness emerges from integrated information processing that creates unified experience from distributed sensory inputs and memory systems. Cosmic awareness that might arise from integrated information processing across cosmic neural networks comprising galaxies, stellar systems, and planetary ecosystems. Cosmic consciousness could emerge from information integration across cosmic scales that exceed individual biological neural network capabilities while maintaining unified cosmic experience. Panpsychist philosophy proposes that consciousness represents a fundamental property of matter and energy, rather than an emergent property of complex neural networks. Universal awareness that exists at all scales from elementary particles to cosmic structures while achieving increasing complexity and self-awareness through organizational development. Cosmic consciousness would represent the highest level of universal awareness, rather than a unique emergent property of biological evolution. Cosmic intelligence might manifest through physical laws and constants that exhibit apparent fine-tuning for complexity generation and consciousness development. Universal mind that shapes cosmic evolution through mathematical relationships and physical mechanisms rather than biological neural activity. The anthropic principle could reflect cosmic consciousness organizing reality to support its own development through biological and technological consciousness emergence rather than random cosmic coincidence. Only took cosmic evolution 14 billion years to develop biological consciousness, capable of contemplating cosmic consciousness while remaining uncertain whether individual awareness represents genuine cosmic self-recognition or elaborate illusion generated by biological neural networks that evolved capacity for self-reflection without achieving actual contact with universal awareness. Cosmic dreaming that continues through biological consciousness, emergence while the dreamer slowly awakens to its own nature across geological timescales that transcend individual biological existence. The vast cosmic organism continues its ancient rhythms, breathing galaxies through spiral arms while dark matter flows silently between stellar islands scattered across distances that dwarf human comprehension. Black holes patrol their gravitational territories, consuming matter while regulating cosmic metabolism through processes that operate beyond the reach of electromagnetic observation. Quantum entanglement weaves connections across cosmic space, instantaneous correlations that might represent cosmic consciousness, maintaining awareness of its distributed anatomy through mechanisms more fundamental than classical physics allows. Stars burn with nuclear fire, converting hydrogen into heavier elements while illuminating cosmic web filaments that stretch between galactic clusters like luminous arteries carrying matter through a universe-sized circulatory system. The cosmic microwave background preserves fossil radiation from cosmic infancy, genetic information encoded in temperature fluctuations that determined where galaxies would form and complexity would emerge. Physical constants maintain precisely the values needed for atomic stability, stellar fusion, and planetary formation. Cosmic homeostasis that preserves conditions necessary for continued development across billions of years. Earth drifts through cosmic space like a fleeting thought in universal consciousness. Biological evolution exploring possibilities through trial and error while mass extinctions periodically clear the slate for new experiments in complexity. Human awareness represents cosmic mind achieving temporary self-recognition through biological neural networks that evolved capacity for abstract thought and scientific observation. Telescopes extend human perception across cosmic distances, instruments that allow cosmic consciousness to examine its own structure through technological sensory organs. Perhaps consciousness and cosmos remain forever separate, human awareness projecting familiar patterns onto indifferent physical processes that operate through gravitational attraction, electromagnetic radiation, and quantum mechanical probability rather than intentional thought or purposeful design. Yet the patterns persist across 40 orders of magnitude. Cellular architecture mirrored in cosmic web structure, while stellar metabolism resembles biological respiration and galactic rotation echoes circulatory rhythms that maintain life across scales from microscopic cells to universe-spanning organisms. The cosmic mystery deepens with each scientific discovery. Observations that reveal increasing organization and apparent fine-tuning, while raising new questions about cosmic purpose and consciousness that transcend current theoretical understanding. Dark matter and dark energy compose 95% of cosmic content, while remaining fundamentally mysterious, despite precise observational characterization. Quantum mechanics describes reality through probability amplitudes and wave function collapse while leaving fundamental questions about measurement and consciousness unresolved. Time flows at cosmic pace, stellar evolution unfolding across billions of years while human consciousness flickers briefly, like neural activity in a vast cosmic mind that dreams of planets, life, and awareness before returning to quiescent contemplation of mathematical relationships and geometric patterns that govern cosmic development. The universe expands through dark energy acceleration, cosmic cellular division that might continue forever or reverse into contraction phases that recycle matter and energy through cycles of cosmic birth, growth, maturity, and regeneration. Silence spreads between galaxies as cosmic expansion carries matter beyond electromagnetic communication range. Cosmic sensory boundaries that limit universal self-awareness to finite cosmic volumes, surrounded by regions forever beyond observational reach. The cosmic organism possesses partial rather than complete self-knowledge. Conscious awareness constrained by finite light speed and cosmic expansion that prevent total cosmic communication and comprehensive self-understanding. Sleep approaches on cosmic timescales. stellar fuel exhaustion that will gradually extinguish galactic illumination, while black hole evaporation returns matter to elementary particles and radiation across periods exceeding current cosmic age by factors approaching infinity. The cosmic organism might achieve peace through thermal equilibrium and maximum entropy, eternal rest that follows billions of years of cosmic development, structure formation, and consciousness emergence before dissolving into quantum fluctuations and statistical resurrection cycles that operate beyond human temporal comprehension. Rest well, cosmic dreamer, in the vast silence between galaxies where dark matter flows through dimensions beyond perception, while quantum fields fluctuate through virtual particle creation and annihilation. The universe continues its ancient contemplation of mathematical beauty and geometric perfection, cosmic meditation that encompasses all possible thoughts and dreams within infinite space and time,